impression, you just do it well for like 5 minutes. It saves you like 2 hours later.
Yeah, the menu's at the top, which is really cancel when you're.
Johnson, welcome.
Yeah.
Oh yeah, have one of
when
these.
you're
What?
Yeah, it
Look at
does.
the geometry question.
Yes, geometry.
I think
Oh, where's the
they
use?
should just extend it.
There's no use for that gap, so why?
Also, I just like the launch pad.
What?
It's not like it's full screen. It's all the screen. It covers it. You can't use anything else.
But
Yeah, I don't know how to change it. I don't think there's a way.
you could have conflict.
Yeah.
How do you bring things to force?
I don't have to.
Why?
Wait, yes I do. Crap. Okay.
Yeah, sure.
You don't have to.
I don't know how to use it, but I'm just gonna control.
No.
Like other rooms down, so you
Oh
need
shit.
Shift is
It's like other public to use. Well, like if you know where it is.
What?
Yeah. Where it is.
No.
Can you like do it? I don't really. I should drive around all this. Like, I see the thing. Like if you want.
Vim user.
You have a plank of wood. Ah,
George.
very crafty. You should put it in your inventory. It could be useful later.
Yeah, good.
This is why I asked to change the desk to
Budget.
How do you get out of this?
actually I asked for
The first thing they have to do next
I
time
don't know
is
why
to
you
get
can't
your desk.
control C.
Why is it telling me stuff?
But yeah, apparently there's this really non-obvious option to not go
Oh, here's the script.
full screen like that. Press Alt,
Yeah, how you gonna fix it?
like
I found them.
something. I don't know. Wait, hold on. This is scarring. Wait,
I thought
does
it's
it even work? No, it doesn't. Like that. Wait. Yeah, I don't know how to demonstrate.
why does this look so
5 minutes past.
It's too
It's so user-friendly.
it
This
looks
board.
too cuddly.
Oh, the done
Like,
video.
okay.
Well, that's it.
So let's
About
just
here,
say I
right?
do this, right? And then when I full screen it, it just goes to full screen and that's not good.
But you only have
So,
limited access.
There's this very non-obvious option of
You
pressing
only have
Alt
limited access
to
to that.
do that.
That wasn't me.
I don't know.
Oh, that wasn't. I just
What do you mean?
Do you only
Very
have
non-obvious.
limited access?
And then when you
to that?
add the full screen,
Yeah, I guess it'll expire in like a few days. But remember, I don't know if you've been tuning in, but we have like so much stuff written
Oh
on this.
look, it's whiteboard.
Oh, we're actually using whiteboard today.
Yes. Yeah. Actually, I'll try paying for it and see what dark mode looks like.
Oh look at this. I remember. Wait, no, I don't. I don't remember.
This is what happened during the holidays.
What is that?
Holiday stuff.
How do you have all of that?
Don't worry, we're over here today.
Which one is this?
Wait, give us that.
When all that stuff out of random being fixed it.
I can't put it in. I need a screwdriver.
So,
I need a screwdriver.
China,
Also, we can't.
second round.
LRA. We can't LRA.
Yeah.
No,
Because
Should be.
mouse input doesn't.
With High Bing's helpful hints.
I'm replacing this desk. But
Wait. Now I have to think.
Oh,
I'll use yours. Just take your desk. So wait for that.
Why does it not work?
Don't move. Don't move. You're gonna
I'll
roll
just show
my
you what happened.
weapon.
Okay, so let's have a look.
Management. The desk.
Water.
yes.
It still works. No.
Do you need another desk?
I just changed it.
Okay, let's try this.
I'm gonna
Right,
give
the
you the.
mouse doesn't input anything.
Why?
I don't understand.
Yo, move.
Natural
Yo,
mouse.
Alex. Alex, I wanna move. Push out.
Share,
My light broken desk.
share.
Drops in the desk.
And then like, okay, so this is
Also,
the Windows
take the
build
leg.
version that I'm trying to run. So I'm just gonna
You have to like
build it on Mac instead. Right, so
Why
I
do you
tried
have
that.
bills? Why do you
Yeah, Johnson, come back.
Because it's the folder.
I'll be like, it happened again. I got mad at the student, and then I hit him with the chair and the leg, and the table broke.
I did.
Math teachers.
Now. Wait.
Wait, I should have how to get
I
China.
think the Windows
I think that's the phone next door.
is that actually spaces.
It does. So that's how it is. But you can just put quotation
Wait,
marks.
stop,
No,
stop.
I need it.
Type echo, type echo.
Now we try and run the one built on Mac, but it's actually the exact same, so it still doesn't.
Type
But
echo.
yeah, that's it.
Do you have an emulator of this?
Windows. Well,
I
we try it. It would be really laggy.
How many kids are waiting for?
Huh?
How many people are waiting
I think it should be everyone.
I guess that's
Helen,还有等谁们都来了。
no, pretty much this
for? Is Kevin coming? Kevin do.
You're not interested
Kevin.
in anyway,
Or
Kevin
he
is
not?
you're not interested in it.
Wait, so
Where's
did
Jaden?
you download
Where's Jaden? Jaden's not coming. Why is Jaden not coming? I don't know. Well, is he certified autistic as well now?
Wait, is there even a map version?
Don't show up.
Still,
I see a pair of basketball shoes.
There is, but it doesn't work for me anymore. I don't know about
See
anyone else,
basketball.
but it doesn't work. I don't know.
You see the one with the
Like,
green ball?
Mono doesn't seem to want
You see the one
to
with two balls?
I'm
Yeah.
gonna.
One, two.
Oh, yeah.
I'm going to get it smart.
Where is it? I am trying to find.
Yeah, I guess just think about the geo question while we're waiting.
Nice. This one.
Yeah, it'll be kind of fun. We can do the question together, and we organize it in terms of Haibing's helpful hints. Even though the first hint I think is kind of implicit. He didn't actually say it, but the first hint I think was draw a good diagram. Okay, so we're gonna start with
Diagram.
This is Alex. Or you.
No, next year. Wait, this year. Wait.
so -1 hint.
No. Is it technically the start of it? I thought it started in like.
Decade.
Does this decade start this year or last?
So trivial. Nothing started. Started a new Tuesday. How about that?
Damn, son.
Oh yeah. Draw a good diagram. My diagram.
Yeah. So just think about this problem until Yang Yang gets here. When Yang gets here, then we
Then you
Yeah,
get
yeah.
the big brain.
Why didn't you comment?
I should get GeoGebra.
I guess he was.
Do you like doing this? Everyone?
What's the right word?
My mom
He
wants
had
me
too
to-
much maths during the last term. I think that's what he has in his mind. Yeah.
Yeah, no, she doesn't want me to watch the non-English.
That's what we
No. English dub. I haven't seen it.
Yeah.
I've only watched Chinese subtitles. Case closed because my mom sort of. Finder. Wow, I'm trying to find something. Can you help me? No.
That's cool.
I wish there was a keyboard shortcut for Internet Explorer. There is no Internet Explorer. I don't know. This.
Oh my god, you have Java.
Yeah, I've Goalie.
You have Go.
Because
What?
I don't know. It was on here, but it's like
Told me?
version 2.6 or something. It's like 4
How
point
fast
something now. So yeah.
How fast is it?
I don't know because I haven't tried anything.
Have you ever
Make
tried
it glider.
control via
Make it glider.
Oh yeah, so like
Can't make it glider.
glider momento. Yeah, wait,
Yes.
it's too small. Help! I can't touch.
No.
I'll
I
just
remember
use
when I
these
said it.
navigation controls that are really janky.
It's just literally
Yeah,
Yeah.
I use arrows. I go too fast.
Arrows, oh, they do have that.
You're just really good at those.
I do like what they do.
Make it glider. Yeah, make it glider.
Light a gun, I can't switch up.
It's a block. Okay.
I'm making premium.
I already have no idea how to.
That's the lightweight speed. I don't know. These boards will expire.
Have you ever tried to copy in person?
No.
It was. I tried and I did
Doesn't it just copy like byte data?
an image
Into
those.
If it's a colored image, would it copy like
And just take a screenshot. Sniffing to D and half sniffing to sniffing to my test.
Maybe like what do you
Can you express
wait,
it?
does this have anything that is related to snippets?
Can you specify
No.
I don't know.
So easy.
Yeah, I think so. Wait,
Why does this guy have a laptop?
no it doesn't snip.
because it's
I think it's that
Okay, so here's the
Wait, Jordan. Are you year 8 this year?
tools.
yes.
Did, Alex, did you consider joining the whiteboard with the laptop?
how to join whiteboard.
Go to whiteboard
Wait, can you join?
Yeah,
and then type in that.
you can even draw on it.
thing.
Yo!
Watch.
You can
Ah,
Should I do what I
Where
I
is
don't have
this?
internet
You
connection.
can try.
Where is
Because
this?
I don't want to draw my book. I just want to like draw the
Wait, how do
practice the events on the whiteboard.
where
Yeah.
is I don't have internet
Where did you
connection.
draw this?
Blah.
Why?
Yeah. Okay, it's time to
Whiteboard.
find edgy.
What is this
Wait,
called?
no.
What is this for? How do we draw it? How do we? It's on the spot. You have a laptop?
Eduvision. Wait, I can't tell which one it is. I'm just not.
What's the password?
Where did you draw this?
My phone probably.
This
maybe
is, we're going to the
has
right,
that
to the far right,
Wait, to the
top
right.
top right. It's an infinite
Oh,
whiteboard.
I
Sometimes it's hard to find where we drew stuff.
How do
I
we draw it?
see. I am.
So just go to whiteboardfox.com and there's a bit that says enter the whiteboard ID, and then you
What
just
website do we go?
whiteboardfox.com.
Oh, whiteboard.
Okay, hopefully there is internet connection.
Yeah, or Ryan will give it to you.
Okay, I did it.
Why does Ryan have to watch?
Do we have to draw an accurate
Whiteboard.
diagram on there?
Oh no, I'll eventually give one away to you. But like,
It says pricing. It's telling you to
But
pay
but
for
there's a no, you just have to enter the link.
it. Okay.
Wait, I have to enter whiteboard ID.
That's very long.
Guys. This board expires on February. Why does it expire on February?
Connection
Because
to
it's
it
server
gets
14
released.
days.
What?
Go.
It's like a free trial thingy.
I don't know,
Okay, I think I joined,
but I think you can choose the expiry date if you pay for it.
but I can't navigate.
Did you guys pay
because
for it?
it sucks.
Do you guys pay for it?
The
Not yet.
other
Oh, I'm
board
going-
is
Diagram.
I
Oh,
might
right,
start
right,
paying for
because
it
it has,
closer
like,
to that date.
Really?
The other board expired.
Where the hell is that?
Oh,
line?
yeah.
It's still loading.
I think it expired.
What's the Wi-Fi, Ryan? Ryan?
Yeah.
what?
It's actually
Eduvision.
What's the password?
Haha, Ryan.
Already
look at
forgot.
this.
What's the password?
Something.
I don't know. It's
It's at the front, isn't it?
There's like
Wow.
there's literally
It's
two.
still loading
there's
diagram
two
because the
education
diagram's
Wi-Fi.
too big.
Yeah,
Oh,
the
it's
one
here,
that
I
says
can see it.
Eduvision.
this is
Oh,
business.
I just.
This is like trying to
This
make
is-
this iPhone.
I should probably
This is
bring my
a
laptop
work.
next
This is a work.
It'll be easier.
Yeah.
I
Sorry,
actually
this
literally
lesson will be
don't
pretty
know.
relaxed so that you can get prepared next time and
I'll
stuff.
just call my mom right now. She'll send it over.
Actually, I might.
Are you
want
serious?
To
She, we live so close together.
Oh, okay.
It's like
Reminders
5 minutes
is
drive.
just reminders.
Which corner are we going to?
Wait,
The top
reminders
right.
is literally just a check.
Oh, it's still loading. I found it.
Actually,
Oh, I got it as well.
No, I think there is
Wait.
one though.
I drew a triangle.
How did all of our notes go on here?
Wait,
Huh?
How the hell did all of our notes go on here?
wait, really, bruh?
I don't know.
Do something.
This is bro moment.
Wait,
Wait.
so
Every
that's-
time I
no.
click something,
Apple.
That is.
the server
Oh yeah,
loads.
apparently there is for some reason
Yeah.
Microsoft Word is
Am I stupid?
just on. as well as.
I'll reveal the diagram at 5.
I don't know what the publisher's on here. Or...
I just realized it's not
Can we
one.
just
But yeah,
all
they
run?
exist.
Hey, why do I not have the final line?
Let's try it
You
because I
shall
haven't
pass.
seen.
Who wrote that?
I haven't seen.
I drew it.
one.
How come nothing came out?
So like
Where are you?
Right
Okay,
here.
it's
I'm
still loading the
drawing.
diagram.
Oh yeah, there it is.
Oh yeah.
Okay, I'll undo
Ha
that.
ha ha. Sign
I
in.
undid that. It's tiny. I need better Wi-Fi.
what is
The Wi-Fi is really slow right now.
What is it called though?
Yeah, it's like only OGs can use this.
Only
I find
OGs.
it really messy,
What?
Cool.
How
Do
do
you
you?
know the
and I always like
No,
saves
I
the
forgot.
files in
Is it
random
really
places, and I always
Huh?
lose the files.
All I know is that it has a hyphen.
Yeah. Jason, go check the Wi-Fi password.
Activate.
Are we allowed to ask for Wi-Fi password? Also, are we allowed to ask for
Okay.
password?
Yeah, Ryan should know. Wait, Ryan, do you have it?
Let's see.
Do you know how to get it? Hook Jackie up with the Wi-Fi password.
I don't know.
Okay, I will show
You can go to the
Wi-Fi.
front.
I've already
You have the
forgotten.
password.
Completely
I
forgotten.
voted
Huh?
the password.
I've completely forgotten.
The password.
Yes.
Alright, do you have the password, anyone? Or try to get it?
I did.
Because you can't.
Alex,
be
can you
the
tell
boss.
George the password?
He's selling
He has-
No,
six.
I know what the.
Which one is
like,
it?
I have the Wi-Fi.
5G one?
Oh.
16 one.
It doesn't.
Yeah.
Why do
Oh, you don't need it though.
Okay, why
Oh,
is
you
it?
don't
I
need
need
it.
to pick up the
Change
phone.
with one.
Yeah, I have
How does it
OneDrive because I attempted. I was like, if I have my LRA files in OneDrive, then maybe I can.
Use LS.
No, there is no LRA.
Why is it not giving me the option to enter a password? That's gay.
It's not I'm using LS.
It's 5G.
It's not 5G, just normal.
Then what's Education 5G?
Some other Wi-Fi.
Why are we getting scammed? Sir,
Okay.
Yeah.
we're getting scammed.
We got
This is the 5G version of it, so I tried to.
Oh, no, yeah.
5G is only for the 4G 5G. From that.
Okay, loaded.
Yeah.
Boys.
Okay, how's mine loaded? Yeah.
What's the other two?
How do you
Stuff.
zoom?
Mine is still
Crowd.
1.7.
Wait, how do you know how?
Wi-Fi says it's not asking for the password.
How do you zoom in and out?
Oh,
What are
you,
you even doing?
Oh, I can't
Oh,
scroll.
Are you
'Cause-
bullying me?
My touchpad is stupid. You can usually
Wait,
scroll,
are we
but
going to be
I
using the
didn't bring my
whiteboard?
mouse. Damn.
Yeah, it's very good idea to ask them
Option.
my laptop.
Zoom out.
Yeah,
Oh,
okay.
yeah,
Do it, yeah.
Wait,
Unless
but
you know
the
what
problem
that
is the menu is really
That's the
stupid,
question,
so you
unless
have
you
to
know
do
what
this.
that
This is what
Because I don't
happened
know
in
what-
like. This is what happened in like.
Oh,
You have to go like.
I found a problem.
Yeah.
I don't know what my laptop is. My mom doesn't know what it is.
You need
yeah,
to
maybe
use
next
touch
time. It's
screen.
not too necessary today.
You don't really need it.
We can use his laptop if we need.
Why is Apple so
Yeah.
Alex, are you willing to
game
share a laptop?
friendly?
No.
Yeah, it's not gamer. This
You
is
guys
not
have
very gamer.
compasses? No.
I have one.
I have a compass, but I don't know if the lead is broken or not.
I have a
Why is it not giving me the?
I am very tempted to.
14 side versus season.
Alex, how do you join Wi-Fi? It's just loading like this. What's giving me?
You have a
option?
touchpad, right? You can't use it. Oh yeah, you
What?
can't. You need to use.
You have to option zoom out, option zoom out,
That's
option
it.
zoom out, options. Wait, option zoom in. Okay, I can't read.
Ryan, this Wi-Fi is racist. Look, it's not even giving me an option to fucking enter the password.
Let me look.
I don't think that would be the
Look at it.
Wi-Fi's
I will
problem. I think
inspect.
that's.
Edivision.
Hey,
Join this network. Okay, your phone's broken.
hey, Ryan,
I thought
where do you think add text is?
Options.
I'm supposed to
Add text.
something.
Enter the text you
Assuming.
want to add it.
What
Drag it.
Oh, I'm going to add a picture. Yeah.
What the fuck?
For some reason, Wowo is one of the most viewed videos.
Why do you?
Even though it's unlisted.
Say that again.
Why is Wowo this?
I don't know. It's like Wowo don't watch. And they're like, okay, I'm going to watch.
I'm just going to hide a little Wowo.mp4. Okay, now I just need to find the thing by zoom out, zoom out, zoom out.
Yeah, so
Yeah.
today's the first Tuesday class, yeah? It's kind of a funny timing. We kind of have week 1 before school starts. And then we're kind of in between this AMO thing as well, okay?
Wait,
So-
AMO.
Options. Zoom.
Yeah, so that's why today we're gonna do a geometry problem and a functions problem. Okay,
Oh,
it's gonna be kind of cool the way we go through it, hopefully. And then
Hiving's helpful hints.
yeah, it's so you can't get too stuck.
Alliteration.
Yeah.
Alliteration.
And look, these
Make sure
guys-
everything's alliterated.
What is the sense of
And then when AMO's over,
the sense of trying to what's the answer?
you know, and Haibing's done with his Tournament of Towns conference, he might even join us, yeah, to help you guys. So that's starting
What
probably
years?
at 12.
Helpful.
Yeah, so
He was supposed to sit next to me on.
yeah, so basically today you get to see geometry and algebra and maybe a little bit of number theory. And if you want, you can even send me an email and tell me what topics you want to do this time. You know, it's totally
not complex stuff.
not complex.
It's not complex. That's important.
I see.
Basic.
Bad memories of
Basic no.
Okay.
I want to learn.
Okay, so the diagram
Basic.
we will start.
I'm going to choose.
You used to put 100 million.
Is it number
Okay,
one?
buddy.
Yeah, number one.
Stats.
How did you
The ad. Into the ad. If you click into the ad,
Wait,
How do
did
you quickly
is that the
draw
ad website or is this
Probably.
the
a
actual?
Wait, this is the
perpendicular
actual
bisector without compass?
From
Wait, then how do you
I think it's good to line it up like vertically or horizontally, so like this.
yeah.
what?
Geometry.
I can't do the online.
I think
And you can
it's
even
on-
use the
wait,
grid
it is
lines.
on App Store. Oh my god, are you kidding me now? I have to App Store.
No, do it online. Do it online. That doesn't.
Start though.
Yeah, so we know we have an isosceles triangle, right? But it can still help to draw it symmetrically. You know?
Big.
What is that?
So I'm just copying Haibing's diagram here.
Big on, bud. No.
Oh, it has to be.
Huh?
There might be
So
I'm Michael.
No, no,
Wait,
no,
is there a
no.
Michael online?
That is not
What do you mean?
function.
Yeah, never mind.
Okay, it's control center.
I'm confused with the buttons down.
See, like, not mine.
Okay, we need line.
That's
Oh
me.
no, we need
That's me.
perpendicular bisector. And no new point. Okay, we have an isosceles triangle. Wait, we need a. B is supposed to be the.
Just rename the points.
Yeah.
This is very user friendly.
How do I see? C1. B.
See underscore.
I see.
I see it too.
I
I'll stop.
see it.
I like select 40.
I'll stop.
I see
Okay.
Wait, that was supposed to go through CI?
What? Okay, now I will get the.
Yeah, actually, even drawing this diagram, there's like a lot of little hints that are kind of already part of this diagram, right?
Wait, why is
Actually, two of them may or may not be useful.
Oh. Isn't
It is very, it's very reflective. Turn it around so the right side.
How do I even geometer? Okay, now we have angle bisectors.
Yes, now welcome to diagram.
Diagram dependence. Oh,
You have to find
okay, now I need the.
the point B.
Okay, I'm
D,
just going to get the mid, because I'm.
Get the midpoint of B and D. D and B.
No, I should rename this I.
Oh yes, it's actually
Yeah, see, can you see even in that little bit of a, it's just a silly thing, AP equals 3PC, right? That makes P at the midpoint of CN.
The.
Yeah.
actually
It's actually I.
I see.
E?
And the midpoint of E and C is.
E does not exist.
Alex. You do?
No.
Okay, so we've got the isosceles triangle. I is the incenter. So incenter is just where the angle bisectors meet. Yeah.
Let's
Okay.
quote from Alex's video.
No. Get out. No.
I can actually join them. I enter the password instead. Alex. Do you know so?
What?
I don't know so.
What is a so one?
Alex, you make your videos for educational purposes.
No.
What's he?
I don't know. Maybe it's educational, but
Maybe
you
it's
can use it how you want to. That's how it be. And
Wait, you're not allowed to.
I know how to make the instant fluorescent.
instant flash.
Okay, because it's isosceles, obviously the height of the symmetry is one of the angle bisectors, right?
Yes.
So
Wait. Yes.
yeah.
Wait. Why is it so hard to rename these? You have to go here, select this, and go like.
Is there a way to keep the menu?
Yes, but my screen is small.
Okay, PI is such that MH is perpendicular
How do
to
I
PH.
zoom? I have to go
What's
here.
M
M?
is the midpoint
have-
of BI.
Wait,
Oh.
wait, hold on. How do
See.
I?
So M is the midpoint.
How the hell do I zoom?
Oh, no grid. Webdem. Oh, that's so much better.
MH is
Yeah,
perpendicular to
That's so much
PH.
more
Yeah.
windows. Wait, there's no bottom bar.
Scott. Some people, for some reason, like no bottom bar on Windows, which is
It looks borderless.
Prove that
yeah.
It's
BH
actually good, but I don't like
perpendicular
it
to
to be too
Q.
used to not.
It doesn't have balance.
Yeah. So
You see
those
the balance
things.
between the top.
So has everything been
bar
drawn in?
and the bottom bar.
That,
The
It's
bottom,
very,
that
very.
looks
the
perpendicular.
bottom bar acts as
Yeah.
Although I don't know where the N
for the rest of the screen to
Huh?
sit on.
It makes it so it's not too immersive. You're still put on edge.
Yeah. So the question is to prove that BH is perpendicular to QH. Yeah.
I see.
Yeah.
Damn.
You see that?
Okay. Okay, now we need the circle. So circle for 3 points. I didn't know this existed.
Okay. So in 4 minutes, I'll reveal the 0th hint. Okay.
zeros.
Yeah. That goes from 0 to 5. 0th hint might be considered background, which if you don't have it, you can get it right now.
Hey, does CI intersect with Q?
Shut up.
Yes, CI is, yeah, by definition, yeah.
Wow, I have to figure out why.
Oh, okay, yeah. So that's part. You can maybe think of that as a pre-hint. Did you know that the angle bisector
No,
actually
but this is incense and not so
meets at the midpoint of the arc?
Shall I label the other side of CI alpha as well?
I don't know why it does.
You want that? You mean alpha on both sides? Yeah.
Wait, this point.
Wait,
So the-
Oh no, I need a zoom. Oh no, I created D.
no wait, it's control Z.
What is
not
this question?
commands.
What do you mean by China second round?
I don't know. China had it. It wasn't the first round, so there were a bunch of people eliminated from the first round.
What is the first?
I think I'll get eliminated in the first round as well, but you wouldn't even make this.
But
It's the first round.
You wouldn't even make China.
Yeah.
is this you? Let's see. Yes, it is.
So is this diagram clear? P is the midpoint
Yes, it is.
Yes,
of CN.
Yes, Q is indeed.
He's just having lots of fun with his app.
Wait, I'm Thonk. Why is C?
Python.
That doesn't look very right. Why does Alex sound like? Why does all Alex sound the same? All the Alex and I sound
What
like.
other Alex?
Let's
Alex Narrow.
He sounds like that when he's little.
F Alex Narrow.
It's kind of crazy. I got that whiteboard up on Chrome, and I'm drawing it on it in another browser, and it's.
Wait, what?
I'm not
What?
even like using the Chrome.
Oh my.
Yeah, and it's Chromecasting.
Chromecast.
Wait, say your
Chromecast. Well, not using Chrome.
Yeah, so this diagram makes kind of sense now, right? So we're trying to show QH.
Prove that. Okay, we need to first figure out why CI is coinciding with.
QH is
CQ is the
perpendicular.
diameter.
Wait, can we still access this file after
No.
lesson?
Yeah, until the first of
CQ
February.
is a
Well, not
diameter.
education.
It is not a diameter.
Wait, no.
Yeah,
it's
I might
not.
start paying
It's
for it.
not.
A diameter.
I mean, it looks pretty good.
Mm.
Just that I don't like how everything's like on one page. It's zoom in and zoom out.
Oh yeah,
Oh,
yeah.
no.
It's better with the touch
How to
screen than you
type.
can try.
Settings.
Really,
zoom,
I can.
Yeah.
Okay,
settings
really,
zoom
I
out.
can.
Settings zoom out.
Does anyone have a
Good luck,
stylus or
dragging.
I have like 3 iPads.
I
Oh
think.
no.
What? No, I've got one there.
Me trying to drag things.
I just tried all the different.
Okay.
All right. So hint 0
Hidden 0.
is what's called. So Hyben's helpful hint 0
Having
Carvings helpful hint 0.
Okay. Triple A.
is Charles'
Why does he
lemma.
laugh like
Have you guys heard of Charles' lemma?
that? Wait, what's that?
Okay, so it's
What's
very.
the one next
What
to
is Charl?
under M?
Okay, so it's a very.
Charl.
What do you mean?
Is Charl a name?
So I need to go to the other.
Charl. Charl. Wait.
Charl.
Charl.
Charles.
Charl.
Charles. Let's search up Charles' lemma.
Yeah, so basically Charles' lemma.
Charles' lemma.
I'm
Charl.
afraid of
What is Charles'
exiting my
lemma?
browser.
Charles law.
Charles' lemma.
It's very simple, okay? So remember how we have a
Charles' lemma. Wait, that's his last
We haven't- we
Charles Lemonade.
we have guys. We have a angle bisector, right?
Yes.
Yeah.
And it goes through like the in-center here, right?
Yes.
Yeah.
And we know that it cuts this arc in half, yeah?
Yeah.
Yes.
Okay.
Does
Well,
it cut the?
So therefore, these lines are equal in length, right?
Yeah.
Yeah. So basically what Charles' lemma says is these lines are equal in length, and they're also equal to the length of, so in this case, QI as well.
What?
So
That's
Q
what I-
QA equals QI.
Oh, okay.
That sounds like a Victor.
Does that make sense?
Yes.
Let's make circles.
Interesting. So this equals.
No, it's keep. This equals that equals this.
I guess it's
So
just like a
this-
special part of this
is this.
Makes circles.
in-center, x-center lemma thing.
Okay, how do you prove this? Well, you can see that we need to prove that
I
it's
keep
an
confusing the
isosceles.
incenter with
Oh
the
wow, that's true.
triangle.
Alex.
It's true. Wow.
Hmm.
Okay, Q is
Commands. Wait, no.
Control Z.
Control Z.
Control. No, control is not at the edge. I'm so cute. Why is
Alex, are you a MacBook user or Windows user?
I usually use Windows.
What do you mean?
Usually,
Like, do you use like?
but now this exists. So yeah,
What happened to your old?
it still exists. It's just thick.
What is it?
This
This
going
is
to be your
this is slightly less thick, so it's gonna be less.
Slightly less big.
Why does it have so many?
Because this weird case thing that you can take off, but I don't know how to. But I can't take
I
off.
can't. I'm really good at taking off those cases. By breaking them.
Okay, let's see.
Okay,
Can
just
we
get-
take this off?
I'm extremely good at breaking stuff.
I'm extremely good at technically removing it. Okay,
What does
shit.
that mean?
I can't
It's
delete
technically
this.
already.
Come on, guys, can you prove this?
No, wait, hold on.
The fact that
Because-
the incenter.
He'd
How
like.
do we? Okay, I proved it. I think.
Yeah.
Wait, did I? Wait, I don't know. Frick. We have to prove that. No, wait. Do we?
Or you can prove like.
We have to prove that QA and BC are parallel.
Let me give you another point. B. How about you can prove also QB is equal to QI, yeah?
So that's an isosceles.
Okay, so the
So
password
MQ is perpendicular.
Dang
MQ
it.
is perpendicular to.
What is that? Doing it.
Is that a known?
It's like one,
MQ
two,
is
three, four,
perpendicular to.
Oh, you guys already proved Charles' lemma?
What? Wait, we need to prove that.
No, this is just part of the hint. But you should be able to prove this anyway. This is not a hard thing to do.
How do you prove these? Wait, are these? Wait.
Do you understand what we're trying to do? So BQ is obviously equal to QA, right?
No, they are not.
Wow, this is.
Yeah.
But we're trying to show that they're both equal to QI, yeah?
Wait, this looks like you're tilting this. It's like a
This is
sphere.
really-
It's a sphere with a triangle.
Wait, how do I prove this? I might just be stupid.
What are you doing, guys?
So the most basic way to prove geometry stuff is to turn it into an angle condition and angle chase, okay? So QI equals QB. You can think of that as like QBI is an isosceles triangle, right?
Yeah.
Yeah?
Yes.
So then you just need to show that BIQ is equal to IBQ. The two angles are equal, yeah?
Yeah.
Okay, we need to prove that this is isosceles triangle.
How do you do? Angle bisector.
Yes. What?
What angle? I don't.
Wait a minute. Hold on. So if this is angle bisector for this and this is angle bisector for this, then it must be angled by this amount. No,
It
it's
must
not.
be angled by this. Then this QA is equal.
Wait, I'm braining.
So
This is also
that's-
like that. Wait, we need to prove that this is angled by the same thing that this is.
What? What?
What is.
Yeah.
Where's Q?
Is angled in the wrong way.
Oh god.
Okay, let me draw the triangle so it's less cancer. 1, 2, 3.
Oh yeah, we have triangle now.
Alright.
What?
QA.
Okay, this is cool.
Your drawing.
Hmm.
Is BIQ to A?
Left click because I'm not.
Or
BIQ.
is that just my.
I mean, it's related to
Also,
A,
right
alpha.
click is 2 fingers.
Wouldn't it
Alpha.
be alpha?
Yeah,
Okay,
come
this
on.
is-
Yeah, it's got alpha in it.
Wow.
Would it be full alpha?
4 alpha. What? No, I is not
I'm
the
losing
center of
this.
anything. It's just called the incenter, okay?
Oh yeah, right.
It's like it's not the center of that circle. If I switch it.
How to do this?
Okay, can I get you started? Actually, I don't really want to get you
This
started. This
is
is
here.
alright. How about this? How about this? I'm gonna make. You'll be like, oh my gosh,
Oh my god.
this is alpha plus beta.
Wait,
Yes.
this?
Yeah.
Yeah.
Yeah, by
Yeah.
primary school triangle stuff. Yeah.
Yeah, no.
So you just have to show the other angle is alpha plus beta. Yeah.
And it is because
But that's.
Wait,
You're trying to say it.
Oh yeah, that's both.
Yeah.
this is.
And alpha's over
Yeah.
there.
Eventually, you'll be just like bluffing me by saying it's bow tie, even if you can't see what it is, right? And then I'll be like, oh yeah, okay.
The bow tie of AB.
Yeah. See.
It's actually
Bow tie, right?
And A unknown angle Q.
So can you see that that's alpha plus beta as well then, right?
So that's isosceles.
Yeah. Everyone needs to be on board with this. You can't be behind on the first part of the first lesson, yeah? We all clear with this?
Wait. Hold on.
Wait,
Um,
wait, so does that mean in the original diagram that BI is perpendicular to MQ?
Okay, I got it.
that one down.
Yeah.
Oh.
Bow tie.
Oh, hold on. You're getting way ahead of ourselves. Okay, so now we proved that this is true, right?
It's like going like
Yeah. Okay.
Like
Hint number 2.
this for
MQ is perpendicular to BI.
wait, MQ is
Didn't I just say that?
Yeah, you anticipated the hint. Okay, hint number 1.
This is really just 'cause it's like is a 2014 map.
HHH number
Yeah, this is
one.
early 2014.
So let me just write it here.
Where underneath the cell.
My pen's not working. Use the touchpad. So hint number 1.
Yeah.
You
So
shall
you
not
can nail.
pass.
1.
There's a you shall
That
not
means
pass
stuff
like
can get stuck.
Yeah.
10 squares underneath.
There's actually lots of funny stuff that happens on the infinite whiteboard that you don't really hear about unless you're logged in and roaming the infinite.
What happened?
What?
Oh, someone deleted the right boundary.
Okay. MQ. Oh, someone deleted one of the angle bisectors.
Who deleted?
My one is still loaded.
MQ is perpendicular to BI. Okay.
Yeah.
Can people see why that is?
Yes.
Wait.
Isn't it because
Okay, if you can just kind of wait for a little while and then.
When I finish loading the
This is a good exercise because it's just a string of really like. I mean, there's nothing so sophisticated in here, but they string together nicely, yeah?
MQ is.
So the next hint is MQ is perpendicular to BI.
yes.
Well, it's isosceles.
And if it's perpendicular.
Ah.
Yeah, that's another.
So you're saying because now you know that BIQ is isosceles, the midpoint is the perpendicular bisector, right?
Yes.
Okay, I hear you. That's good.
You need to use the board.
Wow, is it not loaded?
Oh, I'm not even like using Chrome right
This
now.
is basically. No. Yeah, he's hot. But.
Ugh.
Wait, if BMHQ is cyclic, then wouldn't that mean that?
Wait.
Would that?
Ah.
Wait, what?
You're saying that if
Would
B
that though?
Is B what?
so you're saying if BMHQ was cyclic, right?
B hem.
With BQ as the diameter?
Wait.
Yeah.
Guess the 3 point. Where is the stuff?
Is it? I can't.
Anyone
tell.
hungry?
I actually
Huh?
can't.
Your food.
Yes, it is. Like,
Yeah, I'll go get
wait.
Wait, move B around.
Alright, hand it out.
Wait, no.
I'll hand it out. I'll just like bring it around the class.
Yeah, it is cyclic.
More than enough.
Yeah, but
Yeah,
how?
Oh no,
We
I'm good.
cheated. We
Yo, you want one?
I'll have some
figured
later.
out that it was
I don't know
cyclic
what it is.
somehow.
Eat it.
It's high.
Go on.
It's pi.
Go on.
What?
Oh my god.
Dude, EduVision
What?
pies are like weird.
My mom made
Because they're not
I don't know
hot.
how
That's
long
why.
that was.
Probably.
No, I have some later. But yeah, it's not hot. That's the problem.
I've only eaten them like
I
once
mean,
and then
sure.
like, yeah, and then I never ate them again because I don't know.
All right. So you're already starting to see now we have a condition that it suffices to show BMHQ cyclic. Yeah,
Yes.
that's good observation.
What is
And to
supposed to
prove
reply?
that it's
What's a conic?
Right.
Bone slice thing.
I don't
All right. We call this point R. So hopefully you guys have your own thoughts too. These hints are just there for when you're really stuck.
What's
Yeah.
the awful?
So the R is the intersection of PH and MQ. Yeah. You know how PI goes
Yeah.
all the way? Yeah, that intersects MQ. Let's say at R, okay?
But why though?
Hint number 2. Yeah,
Is that a hint or a construction?
something about R.
Wait, I'm getting okay. I need to mirror my diagram so that it's
Just move your A to the other side.
this. Okay, there we go.
So can you think of something interesting about R?
It's an
I-
intersection.
H5.
Think of like
Oh no.
As in, you have now that MQ is parallel
Why
to.
does it look like it's in the
This is
middle of
R.
everything?
All right. So it looks like you have very good instincts. R is the midpoint.
Of MQ,
Yeah.
but why?
Yeah, good.
X for that. Sorry.
Why?
X.
this is
Why?
So hint number 2, R is the midpoint of MQ.
But why?
Yes.
But why? Yes. We can't give you everything now.
Wait, yeah, I know because it's like because P is the midpoint of C. So and MQ is
Oh,
Wait.
and wait.
parallel to CA. And, wait, how okay. I don't know what I was.
Yeah, right. MQ is parallel to CA, yeah?
Okay.
So yeah, but yeah.
And I mean, CN.
Yeah, okay.
CN is equal to MQ. Oh, I know it is.
Yeah, so like, yes. So since P is the midpoint of CE, then R must be the midpoint of MQ.
Why?
Because it's like similar.
No, but
So
what if you
that
move
means-
MQ up?
What?
What if you move MQ up?
You can't.
No.
It's fixed.
Because-
and it's fixed into
Because
I know.
MQ is parallel to CE, and
CE.
and they share an angle like around I. So
They do.
well, they share opposite angles. But,
according to the right.
I need to.
No, but how do you know if MI is equal to IN?
MI is equal to IN.
And
Okay.
E in your diagram.
E.
Who's online?
Oh,
Huh?
okay.
Who's online?
You
I'm
don't
a
know,
bunch of
but
people.
they're
How
similar.
many?
So that's
Like-
all you need to know.
3,
That's the
In fact, they
James?
aren't equal,
4.
We introduce ourselves.
but they are similar.
Yeah, in time.
So yeah, triangle IMQ and triangle
Oh, true, they are
IEC
similar.
is similar. So therefore R
Oh,
is
yeah,
the
they are.
midpoint.
True. True. Hi.
So is it clear that R is the midpoint of MQ? Right?
Yeah.
So when you have those parallel lines,
Trying
they
to
make similar
introduce
triangles,
myself
yeah?
gently.
Yes.
And so the ratios are all going to be basically equal to the ratios.
Ye.
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 Your.
Ye.
Okay, now we know that.
What can we do with this information?
Yeah, so
that
the
we
ratio
have
of
now?
PI to IR is common between two pairs of similar triangles, right?
Yeah.
So then
Yes.
the bases are actually equal. Yeah, MR on PN is the same as RQ on CP, yeah?
Yeah.
Okay. So that's nice. So like the thing is, if you're gonna introduce R and it has no use and no nice property, then you're kind of just wasting a label, right?
Plus 5.
But there's something helpful about R.
This diagram is giving
This I will rename this to N to be consistent.
And for.
where's H again?
Huh.
Oh, so
What's the first one that comes to mind? C plus MRQ.
We are trying to prove that. Wait, I forgot.
Oh wait, it's
We are trying to prove that. Wait. Wait.
Yes.
It's the four.
Actually, so hint number 4, or the next hint,
Look. We are trying to prove that book.
I think we skipped a hint. Like when you noticed that BMHQ had to be cyclic,
Yeah,
That was a hint.
Wait.
I think that was a hint because now you can get another condition for the perpendicular thing, right? Because you don't have like the thing that's annoying about that condition as it's given, right?
Oh wait, it's a circle, which means wait, we have to put that in some.
We have to prove that it is
B-
semicircle.
BQ is diameter.
Yeah, okay.
You have to prove that BQ is diameter.
How do we do this?
Um,
Can we prove that this is symmetric? No, it's not symmetric. Well, then we need to prove that something else is. Oh, wait, no, that's not correct.
BH.
Yeah, so for BHQ to be 90 degrees, BMHQ has to be cyclic, yeah?
Yeah.
Wait, really?
Yeah, because BMQ is 90 degrees, right?
BM.
Yeah. Wait, yeah, okay.
Yeah, so, but that means you can shift the focus from the 90-degree angle to another angle even, yeah?
How do you make it the diameter thing?
You can't exactly.
Yeah, we have to prove this thing.
What's the point of R being the midpoint to M?
Wait, if R is the midpoint. No. Hold on.
Hold it.
Can we move that to like. No, we cannot. We trying to solve that. Can you do. No.
How to find this
Distance. There's a slight problem. They are not very exact.
Okay, then. Control.
Yeah, they are not symmetrical. We trying to solve what you want.
Can you somehow prove BHM is the same as RHQ?
RH.
BHM?
Bum.
RHQ.
BHM. The angles BHM and RHQ.
Yeah.
Wait,
BHM.
are
Is
they?
that possible or is that not?
Well, why RHQ? Why not like
Well, if
BHM
they are the
why not
same,
MQB? Like the bow tie, yeah? So BHM is like standing on BM, yeah?
yeah.
So the other angle that's standing on BM is BQM.
Yeah, BQM, yeah.
Yeah. Yeah, so you can try to show BQM is equal to that.
But that's only if it's cyclic.
Hey, look, they're the same.
No, this is 31.1.
Oh,
But if
Oh,
they
no.
are equal, then it proves it's cyclic.
wait. H might be blocking the point one.
Maybe we could start a big angle chase in this.
Wait, I don't.
You need to move the H out of the way. Move the H.
Wait, I can't use math. Oh, look, it is
they're the
equal.
same.
Wait, I believe your hypothesis was correct, but I don't know.
Alpha.
Wait, but we need to test it.
Hey, look.
Hey, look, it
Move
works.
H out.
Yes, these two angles are indeed the same.
Well, we need to prove.
But we don't want to do that. We want to do something else.
This is not.
But how do you do that? It doesn't have a delete key.
Press the bin button.
Yeah, so a couple of people online have already solved this problem, yeah?
Wait, did they solve it just now?
Yeah, so the second person solved it just now. The first person solved it a few minutes ago. But don't worry, they're a little bit advanced.
What?
Or do worry, they're a little bit advanced. See, it works either way. Don't worry, it doesn't mean anything. See, I could say, don't worry, they're advanced. Or, do worry, they're advanced.
I mean, can you tell us?
I said the opposite things, but drew the same.
Now let's prove this quadrilateral, maybe. Does that work? So this thing. Wait, does this Oh wait, so this. Wait.
We need
You could do anything. So we prove the sum is 90 degrees.
Mm-hmm.
BQH plus QM H is 90 degrees of this is a circle.
Yeah, maybe I'll draw in some angles. How about
What?
this?
Yeah, this is confusing diagram. I made it too confusing. We have to prove this angle is plus this angle is 90.
Is this clear? This is beta minus alpha.
Wait,
This
which
angle.
angle?
This angle.
Is this RIN?
Because
Uh,
Kate
RIQ.
Are you saying the diagonal is it x? Yeah.
what?
Beta minus
Did you guess?
alpha?
Mm.
Because oh yeah,
Mm-hmm.
yeah.
Very good. So we see we're creeping into the angles that we need, yeah?
If
What?
that's beta minus alpha and
So is it clear that this angle is beta? Hmm.
yeah, because there's right angles and that's vertically opposite.
Excellent. So we're getting closer and closer now, right?
Wait, what?
Wait, so are you streaming on YouTube?
Mm-hmm.
Everyone can see.
Everyone can see the screen.
Oh.
It's a screen share. They can't see anyone here.
Isn't there a 15-second delay between
Maybe, yeah.
because every time I see text
Have you done
appearing
Python?
and then 15 seconds later the
No.
video
Have you
writes.
gone
Ah, okay.
No.
Yeah.
Have you ever seen
No.
Have you ever?
Yes.
What is it?
You may have heard of the 27th. How do you do this? Because I'm brain dead. Wait, how do you prove this anyway? Like,
That's what we got so far. The beta minus alpha. Are you okay with the betas minus alpha?
no, I don't get it. That was that one.
Oh, because this angle here, right? So the beta down the bottom is the exterior angle of that alpha, yeah?
Can I write
Triangle.
in
Wait,
probably
yeah, okay,
useless?
So that angle at the top is beta minus alpha, yeah?
yeah,
Because beta equals alpha plus that angle, yeah?
yeah.
So that beta minus alpha is vertically opposite the one that's here.
So that's beta minus alpha.
Yeah. And then the other one, see, can you see in this the right triangle here? That one's 90 minus alpha, 90 minus beta, right?
90, yeah.
And then it's vertically opposite that 90 minus beta, and then that's 90 degrees, so that's beta too.
Yeah, that is also right.
Right triangle.
Yeah, so, okay.
Okay. So we're creeping towards the angles we need,
So
yeah? So now the goal is to find some angles that are actually inside those bow ties, yeah?
So 90 minus beta.
So for example, can you see where this angle is alpha?
which angle? Oh wait. Is that
So that's
supposed to be
alpha.
BQM or BQH?
Huh?
Is that BQM or
BQM.
Wait, that's alpha? Wait,
Um,
that's because. Wait, no, that doesn't work. Oh wait, that's why it's alpha.
Wait, why?
Because alternate angles.
Yeah. On parallel lines are equal.
Which one's alternate?
So MQC.
And yeah, oh yeah. Yes.
Indeed. So if we want, we can try and get that alpha. So if we already have an alpha there, we can try to get an alpha
In BHM.
BHM. Yeah, that's an option.
New one's the new tab. Get blocked. I don't know. Wait. Okay. Wait. Inhale. No, it's not. Hey, is this concurrent? No.
Diagram. Oh my god.
I don't know if this is already used, but MRH is B. Beta.
MRH
No.
is what? Beta.
Me trying to find something that's not diagram.
Yeah, that makes sense.
Guys, we're claiming that MRH is beta.
MRH.
Or MRI or MR.
Wait, RMH or MRH?
MRH.
Oh, so you're using that idea again, basically, right? Alternate angles.
Yeah. MRH.
Okay, I'll use another. So you're saying this is beta, yeah?
Yeah.
And
the other one's beta as well. Wow, and you know what that means? That means wait, no,
That means that no, it doesn't.
Does PH intersect BQ at any point? And PI intersect
Hiving's helpful hints.
I'm going to try to connect it.
Yes.
This is basically 2B2T. Join.
Q, obviously, Q, 812. Okay.
Drop. Am I?
How do you
to what?
Wait, if that's beta, then that's
beta.
okay. That makes sense. I'm being good.
Is BH parallel? No, sorry. It's is it though?
Is what?
Is MH parallel to B? I don't think so.
MH Parallel
Just
to
a casual.
what?
one.
BQ.
Casual.
I don't think so.
The Bible says gay
people.
Okay.
and don't.
Well, why don't they get high?
Hmm.
But then you have to realize that everything, all the points are actually diagram kind of true.
Me when the I just realized something. H is on BA. How the how or so I
How?
how
How did
how did you obtain so many hows?
how?
How? Okay, let's wait. Yeah, why did I say let? No, they in
Oh, the
Freedom
animal
Fury, they literally just say they don't say let's battle, they just say let's. Okay.
No, I think we were meant to get it by now.
Oh.
That's it. We got all
Wait.
the hints, and now we just chase the angles.
What
Okay,
happened?
so we're not being very.
What happened?
Okay,
Well-
let's chase that.
Well, it's all about sort of where you're dedicating the actual energy, right? The people at the back are sort of doing something other than.
I need to brain drop.
Yes, it's the first week back, I guess,
I
for
need
some
to
of you.
brain. Come on, you can brain. I believe in you.
So all the people that were here last term, Alex, the people who were here in the holidays have caught up.
I was here in the holidays.
Yes,
Who wasn't here in the holidays?
Alex.
No,
A minus A.
too expensive for me.
Really too expensive.
No, it's actually too expensive.
It's like free, just ask like his mom to.
What is it?
How is it free?
His mom doesn't mind. His mom keeps the whole cost free. Fine, yeah. What?
I don't have the monies.
That B. No, that's not.
I don't have the monies.
It's not big, it's big.
That's not a B. That's a scheme.
I just reset myself
One,
because I'm.
two,
Wait, wait, no. That's
those one.
yeah. What do we do about MQH triangle?
MQH.
Like, what do we do about it?
Yeah, need some angles, huh?
I mean, isn't that the whole thing you're trying?
Yeah. If we can find one angle in that triangle.
We need something in the
One angle is enough.
probably.
Pretty much. Like you know that MQC is alpha, right?
Yeah.
Hmm.
Interesting.
Why are you playing Tetris right now?
Animation on. What does it do? Click. Oh my god.
I forgot to.
Oh look, it's gamers.
hit to the top.
Hey, push the button.
Oh wow.
Why? Oh.
Amazing.
I just saw a circle in that drawing.
Kevin is very weird.
What is a romantic life? I don't- I'm gonna make a little diagram, and which means that we need to make this triangle not similar to this triangle. Brain dead. Wait, no, no, no. That's wait. Okay, so M are that. Okay, wait. So that's 90 plus
What is
beta.
what is 90%?
No, it's not.
No, what?
Wait, that's therefore that's wait, yeah, wait, no, wait, that's 90 minus beta.
Oh.
90 minus, okay, so 90 minus, 90 minus, no, wait,
So that's 180.
so that's 180 minus,
minus 9. Wait, what?
okay, well, so HRQ is 90, what, 180 minus beta.
Oh wait, so you're saying BMH is 90 minus. You're saying it's 90 minus beta plus 9. Is that what you're saying?
Wait, what?
What did you just say?
BMH.
What did
Wait,
you say?
BMH is what?
What did you s- What did you
Wait,
say?
hold on, wait a minute. What?
Yes.
Wait.
So we need a
QMH is 90 minus B.
RMH is
QMH. Yeah, it's 90 minus B, right?
Yeah.
So that QMH is it's 180 minus beta, right?
Mhm.
So if you can show the opposite angle is beta, right?
wait, which one?
Then it'll add up to 180, yeah?
BQH.
But these
So for
are-
example, if it suffices to show,
Wait, so if BQH is beta, then it's cyclic.
yeah, so it suffices to show that MQH, yeah, is beta minus alpha, yeah? Because if MQH is beta minus alpha, then BQH is beta, right?
Yeah, we have a beta minus alpha down there, but I don't know how.
Yeah. And you can try to.
Hmm.
This line can make a difference.
2 is better than 1.
What's
exploding
two
me.
Uh-oh.
Oh, look at
Pulling out
that.
the big...
What?
Imagine having exploding me.
Yeah, so the question is, why is that angle beta minus alpha?
That I know it's also. I think. Alpha.
Since that's alpha, then beta is the wait. Sorry.
Yeah, I can't even...
Pistol G.
What?
MQH is also alpha. MQ.
No,
Wait, no,
MQI.
MQ... Yeah.
MQC is
MQH and MQ are the same angle, dude.
no, they
No, they're not.
No, but
MQI is
it MQH alpha?
no
MQI
MQI.
alpha. Yeah, but if you and stuff.
What? Wait. No.
Like true, it's
No, that's just not... No, you're not going to.
calculus.
So somehow MQH is beta minus alpha, yeah?
Well, this is beta minus
Yeah.
and somehow it's gonna
Wait,
go
somehow then IQH is
So, and then somehow HQC is 2 alpha minus beta.
One's fine.
so. Okay, now I'm just.
Sounds like
Wrong momentum. You're not getting it right. I literally went like Discord one. It sounds from the outside.
Okay, I guess if there is a final hint, it would be use R is the midpoint of MQ somehow.
Wait a minute.
I
No.
still can't think.
Wait, R is the wait. The
Supreme stuttering. Supreme stutter.
Supreme.
Alexa.
What's RHQ?
Didn't know.
Don't know what R.
Do we know what RHQ is?
Nope.
If you know what
Rook.
just then RQ.
If we knew, then we would.
But what would it be,
solve-
by the way? RHQ, if RQH has to be beta minus alpha, yeah?
Then RHQ is alpha.
Wait, beta minus alpha.
Yeah, then RHQ would have to be alpha, yeah?
Wait, why is it supposed to be? Wait,
H.
H B F. No,
But if RHQ is alpha, then it's H.
what really?
Hmm.
True. They're not very good ones though.
I mean, put it on. Wait, is Jin coming?
Who is that Jin? I only know hyping
Jin.
stuff for him.
Is he coming this time?
Jin.
So,
He gave up.
Did Kevin give up?
Jin gave up.
Wait, did Kevin do gave up or no?
I don't know.
Oh no, Kevin didn't do.
What's about
No,
Kevin did not do.
Kevin did not do.
My guy said funny.
Did we also do?
Comedical
Why
comedy.
you not have to?
No, because it's in attachment to the
I'll show you.
What is
humans.
6 yet?
No, because it's in OneDrive.
you did.
Why
Why do you have so much time? So many
That's
I have weird
Tom.
videos,
videos.
Why do you have
What
this
songs,
song?
and
I
crap.
am torturing you. I want to hear I am torturing.
What?
That's
I'm
probably
torturing myself.
the quick brown.
So wait.
No, wait, no, that's-
HRQ is 180
What's
minus
the-
beta.
Okay,
Mhm.
let's go.
Yeah.
We are
That's-
going, boys.
Plus the same.
We are going. A song.
Oh, by the way, can you see that if you need MQH to be beta minus alpha, yeah?
Yeah.
Which is the same as this beta minus alpha, yeah?
Yeah.
And you need and then that implies, you know, that RHQ is alpha, yeah?
Yeah.
Right?
Yeah.
Which is the same as like that alpha, yeah?
Yeah.
Yes.
It's possible that the two triangles are similar, isn't it? So wait.
Okay.
I said
I don't know what the delay.
Wait, which two triangles? B and Q and.
So it has to have the beta minus alpha in it, and it has to have the
I don't know
alpha.
what the delay is.
Oh wait.
I don't know.
Pressing the wrong
I don't know what the delay is. It's
So-
going to 1. Because that's like a generic. Okay, no. No, wait, it's -1.
Yeah, so remember this is alpha here too as well, right?
What?
Yeah. Yep.
Wait, is it?
Yeah, just go. So can you see there's a triangle RQ has alpha and beta minus alpha in it, yeah?
This is 39.
Yeah.
And we want this to be, remember we want this one to be alpha and this one to be beta minus alpha, right?
Yeah.
So then they have to be similar, right?
Yeah. Wait, so RHQ has to be similar to RIQ?
Yeah.
Yeah. Yeah.
So
Yeah,
if you
but
want to
there's no
conclude
longer-
the angle condition with similar, then you have to prove the similarity with the side condition, right?
I want to see the latest thing.
Does that make sense?
We need the latest.
What?
Okay, we need to go to OneDrive, attach documents.
Oh,
Alright.
Yeah.
For the section.
Tracks. 170 at random.
Oh my god, you have everything. You have too many bad. Thank you.
Some random save. Probably.
So you got one angle for free, right? The common angle, yeah?
Thank you.
Yeah.
180 minus beta.
No, really. But neither do I.
So if you want to prove they're similar,
Do we have to load again? Why you like
so it suffices to show, yeah?
Yeah.
And it's equivalent to showing, yeah? That triangle IRQ is similar to RHQ, right?
Yeah.
Interesting.
And we already have, so it looks like we're going to do an SAS, right?
So,
Because we already have the angle, yeah?
yes. Okay.
And we want to conclude the other angle, right?
Wait, how do we do SAS?
So we need to show that rusty, huh? Rusty. So RQ on RI, yeah, is equal to RH
I can't track.
on RQ. Yeah.
Just watch.
It's basically
So another way of saying that is RQ squared, right? Yeah. Equals RH times RI. Yeah.
Yeah.
The zoom is wrong. It's supposed to be.
That's
Oh, okay.
Yes. That's why it's so slow. BSA, I was very bad back then.
Yeah. So now can you see there's a very obvious way to use the midpoint
Yeah,
condition, right?
I got debated too.
Yes.
Um,
Like it doesn't matter if you know it works or not. You know that if you got RQ squared equals RHRI, right? And you want to use the midpoint condition, then you need to show that RM squared is equal to RHRI, right?
It's all
Yeah.
flat.
Yeah. But look at where RHRI is now. That's triangles RMH, right? RMH and RIM, yeah?
Yeah.
So that's triangle RMH
Ew.
and triangle
Oh.
RMI, right?
Yeah.
Yeah. And notice you got the same setup. Remember, this is basically the tangent, the alternate segments theorem setup, right? Yeah, there's lots of ways to remember this. So when you have this, you know, like you have a tangent, right? Like tangent. Sorry.
Wait, what?
You have a tangent at this point, yeah. The alternate segments setup is that this angle is equal to this angle, right?
Yes.
Yeah.
Yeah.
Like that.
There's a manual for once.
And what it gives you, okay, if you
Yes.
you kind of
That's a 10-point count generation. I died.
yeah, it gives you similar triangles here, yeah.
Wait. So yeah.
Another way of saying it is it's the power of a
Yes.
point, yeah. So if you have a P, T.
Indeed.
Oh, he'd missed a lot actually in the time he was gone. Yeah, he actually missed a
How do
lot.
we prove circle?
Okay, anyway, that's just the way to remember it. You can just see it directly within similar triangles for now. So basically what we need to show is Rm squared
This is the exact one for
equals RH times I, right? But look what that means. It means Rm on RH is equal to Ri on Rm, right?
This is no.
So Rm, the red line thing, on
Yeah, actually,
RH, right?
smooth.
On RH. Yeah, so basically we're looking at
There we go.
the angle beta is common, right?
Yeah.
And we're just looking at the SAS for Rm.
Pro tip: set your gaming monitor
Yeah.
at 40 hertz.
And it's similar, right? Because they're both 90-degree triangles with a beta in them, yeah?
Yeah.
They both have a 90 minus. So it's true, yeah? Can you see what I'm saying here?
Manual.
So basically RMH, yeah, is similar to RMI. Yeah?
Why do I have
Because they're both 90 degrees and with a beta, yeah? Right? And so then you can get the sides out of that, yeah? So then this SAS will give you RM on RH, right, is equal to RI on RM. Yeah? And that's what we need, right? Because that's RM squared equals RIS. So this is really a down and dirty way to solve this problem, but it breaks it down into steps that you can digest, right? It uses nothing complicated, right? Everything is just angle chasing and similar triangles. Yeah, so sometimes it's nice to see if something forces you to do something, right? Like if you're forced to show that RM squared equals RH RI, then you see if you have that, you have to have that, right? And then you have it. Yeah. Okay, so that's done.
Wait, RI. Oh wait, no one.
Yeah, RI is the longer of the two.
The big one.
Yeah. Yeah, I mean, this is not the only way to do it. So Crystal said online she had a nice solution. Singh probably did it another way.
I want a nice solution. Yeah. Rabbit school track. Hey, you know what's even more rabbit school track? Wait, that's the wrong way. That's the wrong way. Controls to match. Another one.
Alright, so we're going to use the rest of the time to do the functional equation.
This will destroy you. Wait, no.
It's actually
Alright, who doesn't know what a function is?
What is function?
So a function is like this. So we have a function.
This is input, this is an output.
Okay, then. Which?
The question is on the email, but I'll write the question up on the board, okay?
Wow, I don't have my email on this computer.
The question is, so this is 2020
Deep
MC1.
Deep, very deep. There's two inputs.
Okay, you're looking for all the functions for which f of
Two
x
inputs, one output.
plus y plus 1 equals f of x squared plus y plus 2f of x plus 2y.
What?
For all. So if you don't know what this means, then that means you don't know what functions are, yeah?
This is too big.
That looks complicated.
Yeah, so let me just explain what functions are first, okay?
As in, like,
Help me
the
along.
function.
Yeah, what functions are defined to be? If you don't know how they're defined, you're never
What
gonna...
function does this? I have one helpful hint.
Yeah, so there'll be hints for this too, but like, guys, you're like being pretty bad today. As a whole, yeah. It's just not trying enough. This is meant to be easy, actually.
It's like we're not trying as hard as possible.
It's not really like you don't have to try hard. Like focus on trying and force yourself to try. It's just like there's got to be something in your mind. Like what's your purpose? Yeah.
How?
Yeah, and if your purpose has nothing to do with getting better at maths, then you gotta have to reevaluate. Okay, so
How do you color?
what's a function? Okay, so a function, in principle, is meant to you can phrase everything in maths in terms of functions. That's what the selling slogan is. Okay, so
I can't.
who drew that?
Just
You'll never know.
I need to.
You'll never know. There's only one person with black.
Okay, so yeah. So it usually has, so if you look at this notation, right? It usually has the name of the function is f, yeah? And then it has these two sets, okay? So this set is called the domain, yeah? And the second set after the arrow is called the codomain, okay? So basically a function takes inputs and outputs stuff, yeah? And the key to being a function is that the outputs are determined by the inputs. It sounds stupid, but that's basically what a function is, okay? It does reflect a little bit of an old way of thinking where like things have to be deterministic, yeah? And so in some sense, computers are based on functions, okay? Because of this deterministic way of thinking, right? And that's purely based on logic. But computers can also be based on quantum mechanics, right? So there's quantum computers, which may not be purely deterministic, okay? So not everything you think, so even though everything can be phrased in terms of functions, the way of thinking that it presents to you might not necessarily be the right one, yeah? So this is something people have to be careful of. Okay, so that's called the domain, and this is called the codomain, yeah? And basically the only condition is, so the domain is basically the set of all the inputs, okay? The function has to have an output for every single input, yeah? So it has to have a plan for every element of the input set, yeah? Okay. And then every input has to go to something into the codomain, yeah? That's the second condition, yeah? It doesn't have to reach everything. Everything has to be of that type. That makes sense? So this function here, inputs are real numbers. So it has to tell you what to do for every real number. Yeah? And then what it does is it outputs something, and that something just has to be a real number that you've said that. Right? Okay. And then the only other condition is the determinism. Okay? Like once you put the same input in for that function, it always has to give the same output out. You can't put in like 3 and then get out 6 one time, and then you put in 3 and you get out 7 another time.
It's just always like the same.
Yeah, for f, yeah, f will always send 3 to 6 if it did it once, yeah. And so where it sends 3, we have this notation, f of 3. That's where 3 goes. That's the output of 3. If you input 3.
Is the output y?
No. Y is just another like the letter. So you can do y and x independently of each other. That's all that y and x. Okay. Something else you might want to know about functions is yeah. So when they're discrete functions, that's the only conditions. Yeah. So you don't really. There's not really many things to know about functions. Yeah. So maybe as an easy exercise for you, like you can just kind of list the functions that go from x to x. Yeah, where x is like equal to the set like 1, 2. Yeah. What are all the possible functions that go from the set of 1 and 2 to the set of 1 and 2?
F of x equals x and f of, and then there's f of 1 equals 2 and f of 2 equals 1. And then there's like f of x equals 1 and then f of x equals 2.
Yeah, so basically all you have to do is, so you have to always, so with the 1 and 2, right? You have to always define where they go, right? For that to be a function, yeah? So I guess the functions, that's the most obvious one. If 1 goes to 1, yeah, and 2 goes to 2, that's called the identity function, yeah? I call that identity function on x. But you have a lot of different functions. You can also take, like, you can swap them, yeah? 1 goes to 2 and 2 could go to 1, yeah? And then there's some degenerate ones that people don't necessarily think of, is that you can send them both to 2, or you can send them both to 1, right?
Yeah.
So there should be 4 functions, yeah?
But if that was set to 1, wouldn't that set to...
Yeah, see? That was part of the condition. There's no problem with that. There's nothing that has to go to 2.
Oh.
It's just that 2 has to go to something. Yeah?
This pen is not blue.
Yeah, so identity, so if they both send to 1, that's called a constant function, right? That's always there if the other set's not empty, right? There's always a constant function you could think of. It's not as natural because you have to actually pick an element, right? To be the constant. Identity function is natural in the sense that there's an identity function on every set, yeah? But all it does is it takes something as input and outputs the same thing, yeah? Okay. And I guess I want to learn more about functions through this question. And I'm really hoping we can get through it because at this rate, we're not going to, okay?
How?
So look at what this question is asking you, yeah? So usually you're asking to find like an equation, like in x, you're looking for the number x, right? But here the equation is in f. You're looking for the function f. That makes sense?
So we're looking for what the function does.
You're looking for what function can satisfy this equation. Does that make sense?
I don't know how to do this.
Yeah, that's why we're here, right? If you knew what you're doing when you're here, you don't have to be. Okay. Does that make sense? So f just inputs real numbers, yeah? And outputs real numbers. So it has to input every real number and gives out some real number. Okay? And it has to satisfy this crazy condition, yeah? So what does this notation mean? Let me explain this notation here. Like if you have f of x plus y, yeah? What's that even mean, yeah?
Let's do that.
Yeah, first you've input x, right? And f of x is the output of that, yeah?
Yeah.
And then you add the output to y, yeah? And then input all to that into f again, right? So notice that it works because the output's a real number. You can always add 2 real numbers, and then you get a real number, so you can put it back in, right? So that's the main thing. Sometimes you get a bit tricky because, so that's why like you have, like some functions it's nice to extend them even though they look trivial. You don't have to check if they're in the domain or not, right? So the main thing about functions is if they're in the domain or not. Yeah, one of the main things. So here everything's real. Adding things is real. It outputs to reals. You don't have to worry about it. Yeah. Okay. Yeah. So you'll never get like a more kind of baby steps tutorial than this. So pay attention. Okay, so maybe I've put them into hints and exercises. Okay. So can you see this is true for all x and y? So a lot of the information comes from subbing in x and y for various different x's and y's, right? So the first hint, so I guess this is Michael's hints now. These all don't necessarily help you solve the problem directly, but they all contribute to your understanding. Okay, so show that if f of 0 equals 1, yeah, then f of 1 equals 2. Can you show that? Does that make sense? If 0 outputs to 1, then 1 outputs to 2. Yeah? That's the first exercise.
I got it. Where is it? Yeah.
Alright, does that make sense?
Yeah.
Can you do it?
Yeah.
Alright, good. Not too hard.
Not too.
Yeah, so basically, you need to sub in x's and y's, right? So for example, you could sub in 0 for x and y, yeah? So you put x equals 0, y equals 0, yeah? What do you get? You get f of 0 plus 1 equals f of 0 plus 2f of 0 and then plus 0, yeah? So basically f of 0 is 3f of 0. So f of 0 is equal to 3f of 0 minus 1, right? So if f of 0 equals 1, right? Yeah. Then f of 1 equals 3 minus 1. Yeah? Equals 2. See? I'm kind of getting the hang of it, yeah. So there's going to be a lot of things like this. Okay, so the next exercise, given your reactions to the first exercise, is this. Show that no constant functions work. No constant functions work. Yeah? And if you already know how to do it really quickly, the third exercise is show that the identity function doesn't work.
No constant functions work. Well, if you just get like x plus 1, then it's like if the constant is c, then it's c plus 1 equals c plus 2, c plus
2y.
2y.
Yeah.
That doesn't make sense.
And can you see why it doesn't make sense?
Because there's going to be some y that.
Yeah, because it has to work for all y, right? The constant can't survive the equation for all y. Does that make sense?
Yeah.
So like, if f always outputs the same number, yeah? Let's say it outputs c, yeah? Then c plus 1 has to equal c plus 2c plus 2y, right? For all y, yeah? For any y. Yeah? So the point is, this only works for one y, right? Because y has to equal like, you know, like 1 minus 2c, right?
Yeah.
Yeah, y has to equal 1 minus 2c on 2. But y could be anything, so it could change. If it's not that, then the equation fails, right?
Yeah.
So therefore, it can't be f can't be constant. Yeah. Okay. So now show that f can't be the identity function. It can't just output what it inputs.
Plus y plus 1 equals x squared plus y plus 2x plus 2y. So which
X plus 1.
x squared plus 3y plus 2x. That's not equivalent.
x squared plus 3y plus x equals to x plus y plus 1.
No, it's still
for all x and y.
If I look at it from another no.
Yeah, so I guess what I want to emphasize is these are kind of things that you can basically like. So the main thing about solving functional equations, okay, is just to kind of go with the read. Yeah, you try things and then what you see what happens and you just adjust according to what you see, right? That's the same with all maths and all math problems. You're basically observing the problem and you're adjusting to it until you can solve it or you can't solve it, right? What we're doing is I guess these hints, right? They're kind of a little bit unnatural, right? You don't necessarily get the hints, but what these hints are, they're kind of like good things to try, even if you don't know what you're doing. Yeah. So if you don't know what to do, like these are always good things to try. Yeah. See if you can find like some easy function that works. Yeah. Like they're kind of like go-tos for when you don't know what to do with your time. Yeah. So obviously the best thing is just to go with like your reads, but if you don't have any reads, this is like the next best thing. Yeah. Okay, so can you see the identity function works or doesn't work?
X plus y plus 1 equals to x squared plus 2x plus 3.
So try to write it down because it'll help you gain a bit of familiarity with the notation.
Okay, this doesn't work. We need to somehow get out the somehow get the squared x squared thing to work. Because yeah, that's problematic. Wait, with if x squared is nested in one f of x and then the other one is nested in two, then
Yeah. And I guess it's good that since a lot of you just learning functions, these exercises actually kind of tell you what the simple functions are. Yeah.
Okay, let's do x squared.
Okay, so can you see why the identity function doesn't work? So this is where you have to write it down. Yeah. See, what does the identity do? It just takes the input and outputs. So the first output will just be f of x plus y, right?
Yeah.
Because that used to be input. That just comes out, yeah?
Yeah.
And then that just becomes x plus y plus 1, right?
And the other side is
X squared.
Does x squared
2x
does f of x equals x squared work?
X squared plus 1.
X 2x squared plus 2y.
Oh.
I don't think so.
So someone said, wait, does it work?
I don't think so. Nah, it doesn't. But it has to be like something like that somewhere.
Okay, so this is a little bit of abusive language because people call these kind of functions, if f of x equals ax plus b, right? Where a and b are constants, yeah? So like if f of x equals 2x plus 1, yeah? They call that a linear function, yeah? So this is the kind of thing that like it's really annoying because you have to be aware of it because people are calling them linear functions. But when you get into uni or something, like linear has a different meaning.
What does that mean?
Yeah, so linear functions are functions which are linear, right? They're additive and they're scale, yeah? But here linear functions is a function that represents a straight line. Yeah? Okay, but it's a simple kind of function, yeah? It's like ax plus b. So the identity function is just where a is equal to 1 and b equals 0, right?
Yeah,
Constant functions where a equals 0.
I don't think linear functions can.
Yeah, so why not?
Because there's an x squared in
Ah,
the
yes.
right side.
Okay, good. So if you want to sub this in, right, this would be a good exercise, right? Sub this in and see what a and b would have to be. And if you can't find a and b, then there can't be any, right? Okay, so the next hint, I guess, I don't know if we'll go through it.
Let's do quadratic.
So,
What?
yeah, so no linear functions, yeah?
Yeah.
Okay, and then the question is, are there quadratic functions?
Quadratic function is
So you know what I mean by quadratic functions?
let
So f of x is equal to ax squared plus bx plus c, and a is not 0, yeah?
Then
That's a
this
quadratic
is f of, okay. And this. Wait, this is really weird. How do you even get this? So you need this done. A of this. You need to square this entire thing, which is kind of hard.
Yeah, so you can be a bit more like skillful about it. You don't necessarily have to sub all that in every time. Maybe you can kind of see.
Maybe quadratics as well. There'd have to be a negative coefficient. Wait, one minute. This is only this.
You don't have to do the whole calculation straight away. You could do some easy ones, right? You could do like x squared. Does x squared work? You could,
X squared does not work.
excellent.
Oh, that is slow. Going to be answered.
Lama.
You guys going to talk?
Yes.
What we have?
Yes.
Yeah, good choice.
Okay, I need to check.
Did you SDD?
Yes.
Which SDD are you in? There
Oh,
are
it's already
two.
out of order.
I don't know.
Interesting.
I know that.
You have been
Okay,
stopped.
outside. You have STD.
You have STD. I bet SDG will be like, Howard, let's write a Hello World version.
Hello, wow.
What?
So much plus it says two in your right.
Wow.
Oh, by the way, what could simplify your search for the quadratic?
I don't know.
What could simplify your search? Like, obviously, if you had the brute force, you could just put the quadratic general form in and solve for APC, right? But I don't think you do right now. Do you? Can you do that right now? I don't know. I don't know if you have that ability or if it's worth that necessarily that effort. Like in maths, you're trying to use your observations to simplify your problems, right?
Well, we
So-
have to eliminate x squared to be x to. Hold on, that would make you really complicated.
See, for example, if f of 0 equals 1, right? And f of 1 equals 2, you might want to try the quadratics where 0 goes to 1 and 1 goes to 2.
Oh.
Yeah? That would really cut down the kind of quadratics you're looking for, right?
Yeah.
For example, x squared doesn't work automatically then, right?
X squared plus 1. Okay, x squared plus 1, right? Alright.
If you do have +1,
I mean, C has
X, yeah. So,
I mean,
okay,
B
so let's
or
say
A.
x squared plus 1, then we need to sub that in.
because
So
x
that's
squared plus 1 will leave
x squared plus 1 plus
constant 2 on
y
that side and constant 2.
squared plus 1. Oh god, that's very nested.
A plus B is
Um,
doing what, right?
Nested equals bad.
So C
Equals.
I mean, so A plus B is the 1, so you can just try basically see what things are showing.
Wow.
How to get
I don't know, just use the old link. You have the old
So you
link.
can just try X squared plus 1.
Bruh. X squared plus y squared plus 1. Wait a minute, this is a little bit resemblance plus 2 times
this one thing.
2x squared plus 2 plus 2y. This has a little bit of resemblance. I don't know if it works.
I think writing will help in this case.
Okay, I'll just do this. I'll just try it.
I mean, don't
X squared times what? X squared y x squared. Wait. You already have this squared and then you need this. Is this true? I think x squared plus 1 works, but I don't.
Yeah, that's fine.
Because I tried to just.
But a lot less brutish without A and B and C, right?
Yeah.
Wait, so this is plus 1, and then these are each of the terms. Yeah. These are double each of the terms, so I think it works. I don't know. So like this, those ones, and then these ones are in here. I don't know. I'm just gonna do this.
Okay, so let me just write down what you're doing now. You're trying x squared equals plus 1, yeah?
Yeah.
You're trying...
Okay, so this obviously has that part in it. But then it needs these ones.
Yeah, it's just a note. Like when you have a function like f of x equals x squared plus 1, right? That's obviously a function and it's got a formula, right? Like it's obviously determined by x because the formula tells you how to get the output, right? But functions don't have to have nice formulas, okay? It doesn't have to have this, algebraic formula even, right? It could be totally random. It doesn't have to be like a relationship between the inputs. You know what I mean? The relationship between the inputs is the function in some sense, right? And the relationship doesn't have to be this nice one.
could you continue trying to find f2?
Let me just try X plus 1.
Because
Yeah, I'm just gonna try X plus 1. Oh, you.
Connection has lost, bro. Okay, I can kind of.
Connection loss.
Central. I don't have it on here because I used the alpha. I need to actually set this up properly.
Alright, were you guys able to successfully try this or not?
I don't have one, that's the problem. Yeah, this seems kind of sus. Yeah. Wait, no, wait. Kinda sus, not gonna lie, kinda sus.
I'm just gonna try x plus 1.
1 x to the 4 plus 1 plus y squared.
This is the sign here.
2x squared y plus 2y plus 2. I believe x squared plus 1 works.
Oh, okay, let's try it.
Wait, I don't. No, I don't. I'm not sure, but my bad algebra skills. I can't do algebra skills.
Okay, so if the left-hand side,
Can you continue the F0 equals then F1 equals 2?
That's probably not my. But yeah.
Like, could you keep continuing to find
This is my
F.
oh
What
yes,
F2 is after?
that's a good exercise. Yeah, you can like that could be an exercise. Yeah, like once you know what f of 0 is, can you find f of 1, f of 2, all the integers? Yeah. Yeah.
And so far, F2 was just x squared plus 1.
Yeah. Actually, how many do you need to support x squared plus 1 before it has to be x squared plus 1?
How do I do this? Okay, I'm gonna say that because the other one doesn't actually have.
Yeah. So because the quadratic is a, b, c, right? You just need 3 to get a, b, and c. And then it can't be any other quadratic. Yeah. So if you know it works for x squared plus 1 on 3 things, then it has to be x squared plus 1 or no nothing. Yeah. And let's see if it works, okay?
F0 equals 1.
Central.
F1.
Yeah.
And F2.
Yeah, so that's not enough to say x squared plus 1 works, but it's enough to eliminate everything else. Yeah? Does that make sense? Okay. So left-hand side, what does that become? It becomes f of x plus y all squared plus 1 plus 1, right?
Okay.
You see that?
Yeah.
Okay, and then the f of x becomes x squared plus 1, right?
Yeah. That's why it's good.
Plus 2, yeah?
Yep.
Yeah, what's the right-hand side? It's equal to f of x. Wait, I don't need to write the f anymore. I just say x squared plus y all squared plus 1, right?
Yeah.
Plus 2 x squared plus 1
Yeah.
plus 2y, right?
Yeah.
Yeah, seems legit.
Seems legit, yeah?
Yeah.
So can you see on the left-hand side, like, you can think of it as x squared plus y is like one thing plus 1 all squared, yeah?
Yeah.
So you can think of this thing here as x squared plus y plus 1 squared, right?
Yeah.
And so then the x squared plus y squared
Oh, yeah.
cancels, yeah?
Let's go over pinball.
Yeah.
Then the 1 cancels as well, yeah?
Yeah, and so you
And the cross term,
Oh my god.
2x squared.
2y, right? And the 2x squared plus 2y cancels as well, yeah?
Yeah.
T-pose.
And the only thing that's left is the extra
What do you do? SD?
2 on the outside, right?
And that cancels
Yeah.
with the 2 on that, so then everything.
So the extra 2 on the outside cancels with this 2 here, right?
So everything is
Wow.
equal.
I think
Yeah.
you are in my class.
So when an equation is true for all x and y, it's called an identity,
But
yeah?
like, you have to blend them back into it.
And because it's an identity, it means it satisfies the equation, right?
Yeah.
Okay, so actually this is a big step because we actually found, like some random equation, we actually found a function that satisfies it. So that's like a big deal, okay? So you actually found that f equals, so the function f of x equals x squared plus 1 is a solution, yeah? You'll get a like, let's say you get 7 points for the whole question, you get at least 1 point for this. Okay?
Wow.
Yeah.
Very many points.
Oh, a point. Anyways, okay. So here's where you don't want to be cynical and be like, oh, that's the only solution, yeah? That's the worst, okay? Because it doesn't get you anywhere. It's not mathematical, okay? And this is why sometimes doing lots of problems can actually make you more cynical. Because you end up, it actually is the only solution most of the time, if you find one. And then you just tend to think it has to be the only solution for no reason, right? Yeah? Like, experience in mathematical Olympiad problems is not a real thing. Do you understand? This is only there to help you get smarter, right? Like, if you're like in the jungle and a tiger's attacking you and you're like, oh, I remember this some past paper like this, no, like, it's not gonna help you, right?
I remember, according to
Yeah.
the view from jumping to the highest point.
It's like, no, I remember like in the Olympiads, the tigers never eat the person, so it's alright. Like, that's not a real experience, you know what I'm saying? You need to use the problem solving ability to get out of that situation, yeah? Okay. And it's the same. You can't just say x squared plus 1 is the only solution just because you worked hard to get it, yeah? That's not a real thing. Okay? But the thing is, like, people don't realize how many doors this actually opens, okay? Once you have a solution, this opens all the doors for you, okay? So the next hint or exercise, right? It's a bit of a vague one, okay? Is, I guess it's hint number 2 or 3 or something, 4. List at least 10 properties that that f of x equals x squared plus 1 has, yeah?
X squared plus 1.
The function, yeah?
Symmetric.
Does that make sense? And then you'll see, like, see, the thing is, if we started learning the theory of functions, right, I'll just list some properties and definitions and I'll prove some lemmas and theorems, right? But the thing is, like, why did I even list them? Well, the thing is, you look at this function, okay? You list all the things that you think are actually nice or worth noting about it. They're exactly the definitions that we're going to learn anyway in the theory. So they're natural as hell, okay? So you notice that it's symmetrical. We have actually a word for that, right? So actually, you guys know how to draw graphs, right?
Yeah, well, which type of graph?
Like the graph of a function.
Yeah.
The y and the x, let's not confuse them with the y and the x in the question, but like, see how like x squared plus 1, if you draw y equals x squared plus 1, it looks like that, right?
Yeah.
So that's probably maybe one of the first properties of the function that doesn't count. Every function has a graph, okay?
Yeah.
And the thing that makes it a function is that this vertical line doesn't hit it twice, yeah?
Yeah.
So hitting it twice would be the non-determined output thing. Because one thing would go to two different things, yeah? Okay. Okay, so notice someone said it was symmetric, right? It was symmetric about the y-axis, yeah?
Yeah.
So what that's called an even function. So even function is f of x equals f of minus x for all x.
Yeah.
Does that make sense?
Yeah.
So I bet you everything you can come up with as a nice property, you don't know anything about functions right now, right? But everything you observe that's a nice property about this will be something in the theory of functions. Okay, that's property number 1. It's even.
The vertex is up.
The vertex of 1. So it's kind of like you're saying it's like a minimum at 1, yeah?
Codomain is positive.
Ah, codomain, you mean range. Okay, codomain is real numbers, so it doesn't actually depend on the function much. So you're saying the range is positive, yeah?
Yeah.
Okay, good.
More than or equal.
Oh, actually, good. It's greater than or equal to 1 even, right?
Yeah.
Yeah, so far you got the same things I've said, yeah? That's what natural means in practice. Natural means stuff you can guess, yeah? That's what the word natural means, yeah. I mean, there are definitely more technical definitions of natural, which may or may not be right. This one definition of natural is like it works all the time. Okay, so we're like, 4 out of 10 properties.
That's not really tough.
Another property.
Wait, is that the? Okay.
Did it count them or are one's just 10?
Just like I said 10 just because
Welcome.
it's like a reasonably large number. Like,
Is math actually is there actually like major math Olympiad contests happening now?
well, the most important, well, for us, the most important one is happening on the 3rd of February.
We can't do that.
It's the Australian Maths Olympiad.
We can't do that, right?
Yeah, unfortunately, no. Not yet.
But who can, are you able to do it?
Me?
Yeah.
No, it's for high school students.
Oh.
Yeah.
He's gonna get like 2 marks if he does.
It depends on the question sometimes. Like, sometimes you can do it, like, the questions instantly. Sometimes, like, you don't see what the...
Point is.
Like, you don't really understand the question in the kind of the way that makes it easy to solve straight away, and it could take ages. That's why, like, not always the same people. Yeah, so people have fluctuating results. Depends. The time limit is really the main thing. Okay. Yeah.
There is no. There are no fast pickles. What is a fast pick?
But I could probably guarantee I could get 7 out of 8, and it'll be like a battle for 8. Yeah, so that's the variance is all in the last one. Okay, so
Yeah, 2 out of 8.
any other properties you can think of? Oh, continuous. You know what continuous means?
Yeah. Wait. Yeah.
So continuous means... Oh, that's one of the later properties. I didn't even think you'd come up with that. Continuous, basically, I guess as far as you're concerned, it means you can draw the graph without lifting the pen off the page. So it's kind of connected, yeah? That actually means connected. But, like, for us, it's the same. It's continuous.
Wait, what was the word for like the polynomial thing?
Quadratic.
Wait.
Joke. What?
Wait.
Are you talking about, like,
Okay, I can't remember.
differentiable?
Differentiable.
Is that what you're looking for? Okay, if you're not going to come up with differentiable, I'll write that too. Differentiable.
Well, it is different.
So differentiable and continuous is a standard assumption in physics, okay? About real life stuff. So what happens with real life is stuff has to kind of flow, right? It can't just suddenly be like it can't, it has to kind of go continuously, right? But more than just continuously, it has to also go smoothly. So when it transitions, it doesn't just stop and the other thing like starts, like it doesn't transition like sharply. It kind of transitions nicely. You know what I mean? That's what differentiable means. So continuous means it's kind of connected. Differentiable means it's smooth around the edge. There's no edges. There's no sharp edges. So there's no pointy things like this. Yeah? There's like nothing
How
like
do you
that.
go like
close to it?
There's only like that.
if
Yeah.
it's continuous and differentiable, then what's next?
Oh, so there's like sort of an idea that says if it's differentiable once, it's infinitely differentiable. So you can
Wait,
differentiate
really?
it over and over again. Yeah. It's like a little bit of philosophy.
Wait, so differentiable is like infinitely.
Well, that's not the definition, but you kind of you find that when you have a function, or the functions you learn at school, if you differentiate it once, you can just keep going.
What is differential?
If you think about the graph, right? Like, there's for every point on the curve,
Gradient.
you have a tangent line, right? And the slope of that tangent line is the output of the derivative function. So whereas like the original function, like if you input this value here, right? It outputs this value, yeah? The derivative is a function that outputs the slope
Yeah, I
of
read
that
this in
line.
the weird text.
It's telling you the speed of the
So,
function, basically. So the derivative of distance is
I was
speed, like if the function's with respect to time. Anyway, that's kind of getting a bit out of. That's more advanced actually. So the thing about continuous and differentiable, maybe it goes a little. So that's what makes like functions connected and nice and have nice formulas and stuff, right? And that's exactly the thing that's not true about functions in general. They don't have to be continuous and differentiable, right? In general, they're discrete. So these discrete functions, you could, the next point could send like, it could go like way above, it could go down, it could go somewhere else. You know what I mean? There's nothing to say it's close to the point before it. Yeah. So everyone kind of assumes functions are continuous and differentiable in their minds, when in reality they could be really messed up. Okay, so we're still looking for a couple more properties. Anyone in the chat want to say something? Oh, they're probably all at dinner, jigging, or
Are there any America?
huh?
Are you trying to make us envious?
Envious. Oh, haven't you had dinner?
What is an analytic function?
Not really.
Oh, there's food there.
He's a dinner.
I
You reminded me to eat.
Whoa. Well, I just got brained.
Yeah,
Wow.
make sure you eat and stuff. Don't just die.
Analytic function is a function that is locally given by a conversion.
Yeah.
Well, technically, then this can. No, I'm just. Okay.
My mom tried to make me eat dinner
Technically,
before I
this
came out of
is
class, but then it was like
analytic
39 degrees.
Yeah.
It can
Nah.
be given by conversion.
I'll have one of these as well.
But it doesn't have to be.
What's the
Don't say
Yeah.
anything.
Is it made?
I'm vegan. We should be vegans.
How do you know if someone will be? They'll tell you.
Hey Alex. Okay, you're not vegan.
I'm trying to do Bosch head turn.
No, it's like this.
No, it's like this. Eyes.
His nose disappears. What do you get on?
It's like I don't have nose. That's the problem. I don't have a nose that goes like this. Wait, no, there's a scar. That's why it doesn't.
Boss was that. Boss without his mask.
Have you ever
What?
thought how downwards his head actually goes?
Is Howard annoying?
Yes, and
What?
yes, and
Scarf is like over throat. It's covering his mouth.
Wait, his hat annoys Howard Bruce.
what's a hat?
Howard.
Howard is Howard.
Is he annoying?
Your head's the top
He is
part.
horny boy.
I love the bang.
Wait. Alex. Doesn't it Howard?
I don't know.
Apparently he does.
I don't know. He's hitting up a lot according to himself.
How many?
But I don't think he's gotten any
What?
of them.
How many more?
No way.
Line Rider. What is Line Rider?
And that's all.
Head turn.
Uh-oh, you can't
Yeah,
see
head
it.
drinks. Or someone else.
Okay, let's see the head turn.
Like,
His nose disappears. Let's see his nose disappearing in slow motion.
With who? Okay. Johnny?
his hand covered in
Did it get?
His nose just slowly phases out of existence. It like squishes into his face and then his eye appears.
No,
Boss actually has a second
rather doing try to follow the drink.
I need this in slow motion. Okay, I need zoom.
Because we have sports, and then because I'm in sports, so I don't bring along.
Okay, so we need some better analysis on Bosch's face geometry. Look at this. Look. There was a brief moment when his eye is in front, second eye is in front of his nose. However, his nose disappears quickly after.
Mm-hmm.
I think this is just an image warping that scales this.
Oh, by the way, actually, maybe I don't know if this comment will
That's
motivate you or
wrong.
not. I don't know if this comment will motivate you or not, but like, they're making an AI to do maths Olympiads. Okay, so
Wolfram Alpha.
Wolfram Alpha.
Wolfram Alpha. That's not even like.
Kevin.
That's like a.
He done?
I can't even-
Anything can be AI if you try hard enough.
Yeah. No, they should make an AI for Math Olympiad and then put the technology onto glasses.
Oh my
Where you wear glasses to AMO.
I
Just-
long
I'm
to
just-
see the day when glasses can have that much processing power.
Yeah.
They have it
I guess I mean like, will you be upset when the AI beats you at doing maths Olympiads?
Damn it.
Yeah, obviously. Wait.
I don't know. Well, like,
They
yeah.
could beat you at
Well,
doing
it
maths
probably could
Olympiad,
beat
doesn't
me
that
by
mean they
default,
could just
so-
solve all the
yeah, just
world's
saying.
maths problems?
Well, yeah, they get to like
Why is
train on
Rhino
maths
always
problems
stars
100 million hours a month or something.
When I
And like,
pause,
and if all you
when
guys
I
are
pause,
just
why is not
Sleeping.
restart? But
Well,
when I
technically,
but
They
when
don't
I
have to
don't
sleep.
apparently
pause,
there's self-learning robots. Like after they see something they learn.
braining.
yeah,
These are the scariest robots.
Yeah.
Contact.
yeah.
I first saw that robot in Iron Man. It was like Civil War, and then the robot was like learning.
Okay, you didn't come up with any
Yeah, I
other
can't read
properties.
these contact lists.
Nothing?
They're just really unreadable.
You
Does
said-
it have
They
to
show
do with
all
the
of the
graph, though?
connections.
You can look at the graph, yeah, sure.
Like the bindings, but
But as an experience ability, I'm LRA player.
LRA player?
LRA
It
maker.
increases.
What the hell?
Hey, did anyone hear this?
Doesn't explain
What do you mean
why.
increases?
Oh, wait.
Increases.
It's exponential.
Yeah.
Exponential.
Wait,
It's an obvious. It's definitely not exponential. Okay, this is basically
this is just quadratic.
this is the classic non-exponential growth. Okay.
Is this valid to just call this function a quadratic? Like, is that a...
Yes, but we started with this. This isn't getting us anywhere.
Yeah, but it's still a property.
Yeah. Yeah. Like, 10 properties of this quadratic function. Don't say it's quadratic.
10 properties of this quadratic function. Number 1.
Okay, I like what you said. It's increasing, right? But it's only increasing over here, yeah? Yeah? What's happening over here? It's decreasing, right?
Yeah.
It goes
Isn't that-
down.
For all positive.
Yeah, for all the positive, it's increasing.
And for...
All the negatives, it's decreasing. You almost got all of them.
Hey, did you know that control...
You basically got all of them.
Wait, no.
Go on, just like a couple more. 2 more.
Two more.
It's that...
Yeah.
Bruh,
Tried to learn.
I hate it.
It goes on infinitely.
Hey, it increases without bound, right? It's
Increases
unbounded.
without- Unbounded? What? What does that mean?
It increases, but it increases arbitrarily large, right?
Yes.
You see? If you nominate a number, it will always exceed it. Eventually, yeah?
I said it on that.
That's good.
Right.
What's this rubber? That's rubber a big grey thing.
I just need one more.
That's grey. It looks cool.
The big gray.
Okay, maybe this one's a bit tricky. So this is related to the symmetry, I guess. Is for every output, right? Like output here, yeah?
There are 2 points except the
Yeah, there's exactly 2 inputs that could get to that output.
Except for
Except for at the vertex, right? Where there's exactly 1, yeah? So can you see how that works? It's 1 to 1 at the vertex, and it's 2 to 1 everywhere else, yeah? Yeah.
Look up, look up, look up.
No,
Don't.
that's a bad idea.
We drew so much.
So the way to deal with nosebleeds apparently is you pinch the top of the nose.
And you no, you pinch the
You
opposite
punch
side. nose, let all the blood come out.
No, you just pinch the top, and then the pressure will keep it out from bleeding.
You pinch the opposite
I
side
suck
of
at
the
pinching, so I just do
your
this.
opposite hand. That doesn't do anything.
It's really not that complicated. Like there's like some pressure to keep the blood coming, then you just put pressure on it, and then the pressure will make it go back.
Yes.
Hey, put pressure on it, son.
Like you pinch the bridge of your nose, basically.
He can't. He takes me back.
And then I guess what I used to do, that's what I learned you had to do, right? And then what I used to do was I just stuffed tissue into my nose, which worked also.
Well,
But the tissue got bloody and it was kind of disgusting.
Eventually it was.
Pinches.
Yeah. Okay.
Yeah, basically.
All right. So that's all of them. Actually, if you think about the observations we made, okay. If you think about the observations we made, they actually come into two categories, okay? So one is called injectivity, okay?
Injectivity.
And one is called surjectivity.
So,
They sound like
is
something
this
you
like
would use in a medical
is this like
device.
how everything maps to the output?
Yeah, so basically we're talking about like how unique the outputs are, like for the inputs, yeah? So how we said it was 2 to 1, right?
Yeah.
So injective means it's 1 to 1, yeah?
Oh, that means
So here it's not injective, but it's sort of injective at the vertex, and it's 2 to 1 everywhere else, right? So those are all related to injectivity. You see. So the definition: a function is injective, right? Injective. If f of a equals f of b, so if they have the same output, then they are the same. That's what injective means. Yeah. Surjective means that for every element of the codomain, in this case it's the real numbers, yeah? For every r in R, there exists x such that f of x, so every y in R is such that f of x equals y.
Oh, so
everything is output.
wait. So injectivity is 1 to 1. Subjectivity is
Onto, yeah?
like
1 to 1. This is called onto. So remember the codomain was just where the inputs output to, right?
So like
if it's surjective, it outputs every single thing in the codomain eventually.
Also, like subjectivity is like a cubic.
Yeah, it gets everything, right? So can you see the fact that the minimum is 1 is telling you something about subjectivity, right? It's telling you it can't output stuff less than 1, right? So subjectivity is really talking about what the outputs actually are, right? The actual set of outputs is called the range. A function is subjective is the range is equal to the codomain. Okay?
Yeah.
But in general, we can work out what the range is. So here, the range goes from 1 all the way to infinity, right?
Yeah.
So that's the range. You can get anything bigger than or equal to 1, right? So notice all the things we noticed about it, with the exception of continuous and differentiable, are talking either about the injectivity or the surjectivity of the function. Yeah? Even the increasing. Because the increasing is telling you, you notice that increasing functions are actually injective, right?
Yeah.
Because if it's increasing, it can't repeat the output, right? So even just the fact that it's increasing is telling you it's not going to have a repeat on this side. It could have a repeat on the other side, and it does, right?
Yeah.
Okay. So even just like we're just kind of winging observations, right? And they just naturally fall under these two categories, and that's why you define these two things. Yeah. Okay. So, and basically, if you're actually stuck trying to solve the problem, right, you might want to try to prove one of these weaker properties instead. That makes sense? You might want to prove that it's bounded. You might want to prove it's even. You might want to prove it's 2 to 1, right?
Yeah.
That makes sense?
Oh, that's too thick.
So these give you things to try. Wait, what do you say? These give you things to try if you don't know what to do, right? Okay. So actually, just a question about surjectivity here. So to see if you understand it. So can you see, we have these terms, right? We have f of x plus y, remember? That's inside, that's one of the terms, yeah? Can you see that this expression can get every single real number? Gets any real number.
Yes. Yeah.
Does that make sense?
Yeah.
Do you know what I mean by that? So I guess that's hint, and that's the next hint, but yeah.
Well, since y is
So y can be any real number, right?
and if
Yes.
yeah. Yes.
But what if f of x always outputs something to cancel the y or something? And then they always end up at 0.
How's that one?
But X and
Because
Y
Y
are
is independent
related.
of X.
Oh, they're independent of each other, right? Yeah, so maybe we can make a solid proof that this could get any number. So let Z be any real number, yeah? So let Z be any real number, yeah? So then we just have to set Y so set Y equals to Z minus f of X, right?
Yeah.
And then this expression will just equal Z, right?
Yeah.
So then you literally can get every real number. So just
Yes.
put anything for X. You can just let X be like 3, right? Yeah, and then set Y to be Z minus f of 3. Yeah? That makes sense? And then that'll get you any real number you want. Yeah?
Yeah.
So that's kind of like an observation about the subjectivity of that expression. Yeah? Okay, so here's the exercise. Show that the original functional equation, this equation, yeah? Show that the original functional equation is equivalent to this equation, okay? F of 2z, wait, f of z, sorry.
Is this the same Z from?
It's arbitrary, so, but yeah, it's a bit of a hint, yeah? So f of z plus 1, yeah? Equals f of z minus w plus 2z for all real numbers z, and w is actually a function defined to be f of x minus x squared. That makes sense?
Minus W.
So this is a functional equation, right?
How do you take away
Let f
a
of z be.
function with
Oh, it's just like how you have like, maybe you can think of it as this formula. Yeah? It's just like how in this here, right? You have x squared plus y inside the function, yeah? Here I'm just saying like z is the y and w is the x squared. Yeah? I'm just saying something like that.
But isn't W a function?
Yeah, but so is x squared, yeah? I guess all I'm saying is w depends on x. It's not a constant.
Oh.
Yeah? And the way it depends on x is given by this formula. Yeah?
Minus W. What is interesting?
Interesting.
E3CD. Wow.
It's Australia.
I can because I became an Australian citizen.
When? Today?
Like 10:30 something. No, 10:40 something.
AM?
Yeah.
Am I supposed to congratulate?
No.
Wait, how? What? You became. How did you become a what?
You have to like freaking recite something.
Oh, the test.
No, not the test. The test is like like the last thing you have to do before becoming an Australian citizen is like recite a dumb thing.
Did you do it? Or you
Yeah.
What do you do? Oh, yeah,
Online because COVID.
Oh my god. Online?
Yeah. It's really dumb.
Oh, what's it?
My mom's doing the testing.
Oh.
Hmm.
Oh.
I was becoming Australian citizen medium behind.
Because I don't have any intentions of going back.
Z is not fx.
And I want to go other places without taking 2 weeks for a visa.
Fx.
Also, it means I have to force my mom to vote.
Yeah, actually, Z has to take. So Z does. That will work. Yeah, if Z takes the place of x plus
King of
y.
Thieves faces.
Yeah. So you just gotta figure out a way to make that work.
Why is this small? Small. I like how this one has even less. They just progressively get more and more weird.
That's why you have. That's why W is f of x minus x.
Yeah.
How can you be creative
That's
with this? Like this many squares.
And well, 2z is because
How
it's
is
2
being
fx plus 2y.
See, it seems hard at first, right? But when you think about it, it kind of all just falls apart piece by piece.
Wow.
That is the power of our mind.
Hey.
Well, some of your minds.
Daddy, what do you want to do?
Alright, so can you see why it's equivalent to this equation?
No,
You're not really even trying.
I forgot. It exists.
I think the people who are trying are kind of comfortable with it now. Yeah, new space. I'll make a new space. How about that?
You can zoom in a little.
Yeah.
Wait, can you
No.
zoom in? Can you zoom into
Yeah,
that?
but I'll become extra thick.
No, but the pen is really thick once
So-
you zoom in.
F of x plus y.
Wait, so I'm just
Yes.
wondering, is it possible to zoom into like a tiny bit of space?
Yeah, but like then the dot becomes the whole space.
Well,
And you get green dots
You
and
need to get
gray
a balance.
dots when you want blue dots.
So I'm saying this equation for all x, y, yeah,
Yeah.
is equivalent to this
Wow.
expression
it's like
f of z plus 1 equals f of z
which
minus
one has the
w
least?
plus 2z.
Yeah, this one.
Imagine if someone accidentally cleared and then immediately lost connection. So they couldn't.
See, this one. Yeah, this one also.
By the way, you'll never have me guide you through this stuff again. You realize this? It's not like something I'm like willing to actually do. Even. Like, if you don't take advantage of the opportunity to learn something at the right time, you really just miss out on a lot of stuff that follows. That's just the reality of it. I'm not trying to threaten you or anything with anything more than the natural consequences of existence. Yeah, it's a funny thing. Like when you learn something, that piece of thing that you learn helps you learn other things. You know, it's like compound interest in some sense. It's like the little bit of interest that you earn earns interest, right? That's what compound interest is. So the thing you learn, so if you're learning the right thing, it'll help you learn more things, right? So the difference between
Jesus Christ.
where is everything here?
That was just
Copyright.
Yeah. It can be a very big difference, you know. The next time I say something, I have this experience in the other class. Like, they complain they don't understand what I'm saying, right? But then they don't even try to learn it. So the next time I say the same thing and they don't understand still. But the people who tried to understand it didn't understand it the first time either. They don't understand it the second time.
Wait, does that say Z or what?
Z, yeah, it's Z.
Okay.
It's plus 2Z, yeah? This is for all Z in R and for all X in R. Yeah, and we did that in holidays, right? So it just means for all. This means for all. So this is a member of or in, yeah? Yeah, so the reason why there's an X here is because W is actually equal to f of X minus X squared. Yeah. That makes sense. That actually looks nicer than the previous equation, don't you think? It emphasizes the fact that Z could range through all the values. Yeah. Sort of all the not niceness has been put inside one of the brackets. Yeah. Into W, basically. So how can we show that this is true?
Just 2fz plus 2z minus fw.
I've been conditioned to think that two vertical lines is X.
Let me just write this again if this is confusing. So
Because
I'll write this again. This is
yeah, I have been conditioned to think that two vertical lines is X.
Plus 2z. Yeah. You have a condition to think two vertical lines is what?
X.
Yes. Yes, this is indeed X. That's how it be sometimes.
X plus y.
Yeah, I'm gonna X plus Y. Say what? Z equals what? F of X plus Y? Close. Yeah, Z equals F of X plus Y, yeah.
Yeah.
But remember, so to make it properly legit, right? You need Z to equal F of X plus Y, right?
Yeah.
But you're not allowed to do that because you're meant to choose a value for Y, right? So to get around that, yeah? You just have to set Y equals Z minus F of X. That makes sense? So X can still be anything, right?
Big brain.
And then set Z, Y equals to... So you set Y equals to Z minus F of X, right?
Yeah.
So let Z be anything, right? Then set Z, Y equals Z minus X. And what do you get, right? You get F of
this is big brain right here.
Z, right? Plus 1, yeah?
1
equals F of
Z plus... And Z is like... just anything.
Well, Y is what's important, right? Because that's being changed. Yeah? So it's
Wait,
X squared.
Y is the right side.
Yeah.
Oh, wait, hold on. Wait.
Tell me what I write. Yeah, Z minus Fx. Yeah?
Can we turn the lights on?
Turn on the lights.
Yeah, the light go blind.
Really?
I can't really see in the dark, so.
Wow.
I think you
Wait,
see more clearly.
The center of my vision in the dark is worse than the outside.
No, the light does. This is not. This is the light that makes you see this. Like the light going on would only interfere with this light. This is not like.
I can't see my own paper.
Oh, you want to see your own paper? Okay.
I need to write something.
Finally,
No, I'm like really blind.
I should probably write this down so I can look at my.
Right. Wait, that is better actually. You can see the board still perfectly blind.
I can see it less blind now.
You're just blind.
Yeah.
Okay, so can you see what we're doing? And then notice that the last term is just 2 times the thing inside the F, right?
Yeah.
So it's just 2Z, yeah?
Yes.
Okay, and remember how w was equal to f of x minus x squared, right?
Yeah.
So then this is equal to z minus w, right? So you have f of z plus 1 equals f of z minus w plus 2z. Okay?
Oh.
Yeah.
Okay, I get it.
Yeah.
So the W is just
The other stuff.
the part.
Yeah.
Okay.
But notice what w is, right?
Wait, why is it minus? Like, arbitrarily minus.
It could be plus, I guess. But this question could be answered in the next. So look at what w is, yeah?
Yeah. That's f of x.
Like, does w being that mean anything to you?
Well, f of x is x
It
squared
means that it
minus
can
1.
be up.
Yeah, so you suspect.
X squared plus
So you
1.
don't know, but you suspect that it
Does
could
it mean it could be arbitrary?
f could be f of x. F of x could be x squared plus 1, right? If f of x has to be x squared plus 1, then w has to be 1, right?
Yeah.
So can you see that, like, w equals 1
Then z
if and
minus
only if
1.
f equals x squared plus 1, right?
Yeah.
Okay.
Yeah.
So w is actually a character of interest, actually, if you think about it.
Oh,
So you expect it to output 1, right? Sometimes.
Yes.
Yeah. But what if it doesn't? If it outputs 1 all the time, then you're done, right? Then you've solved the equation. So w is actually a very interesting character in this, yeah? Yeah, so maybe I can ask you some questions about w. Can you see that, for example, so these are the exercises for w, okay?
A with battery.
So w cannot equal 0. Can you see that? I'll list them down first. Another way of saying this is 0 can't be in the image of w, yeah? I'm just giving you another fancy notation for that.
Yeah, 0 cannot. Yeah. Okay.
Okay. If w is constant, right? Yeah. What would the constant be and what would that mean? Yeah.
Well, then that depends on the.
And what would it mean? Yeah. And can you show that f of minus w is equal to f of 0 plus 1?
W
For
is
all x.
constant. Would that mean that? Wait, if W is constant, would it make it like always increase? But or it always decrease?
Yeah, so if w is constant, can you see that f of x would have to equal x squared plus that constant, right?
Yeah. So then it would be like.
Actually, if there's anything you want to learn well, I mean, you should obviously want to learn everything as well as you can, right? But functions is something that will reward you much, much more for learning it in sort of the settings that you'll be in.
Complex numbers.
Wait.
Yeah, there's functions in everything, okay?
If W
And it's
is
in the school syllabus as well. And
W is constant, would F have to be surjective?
What's more important, complex numbers or functions?
so,
What?
I mean, in terms of what I was saying, like what would help you learn more other things, it'd be functions.
Okay, we don't need complex numbers.
Complex numbers of like.
You don't need any of these, yeah? We just farm. That's all we need. You see what I'm saying? We just need the agricultural part of the school.
Go to
Yeah?
Technically.
If you want to speak for need, okay, we don't need anything. Yeah?
we don't need no functions in life. We just need to know how to do basic adding and
We just need to
Yeah.
how to grow tasers.
Yeah. You don't even necessarily need to know how to do that, right? Because
calculate
Not farming.
yeah, but if you want to do it efficiently, now that's another question.
I hate complex numbers so much. I couldn't understand. and like half the lesson on the first day.
But you kept at it. See, that's important.
Complex numbers, I don't know that would. But like.
Alright, can you see why any of these have to be true?
Wait, if W is constant, would the function have to be surjective or no?
Would the function have to be surjective?
Yeah, like, would it?
No, because if the W was constant, f would equal x squared plus that constant, right? X squared plus a constant is not surjective. Like, it's always going to have a minimum, right? Or maximum. Well, x squared plus constant is going to have a minimum, yeah? It's a smiley face. It's shifted up or down by the constant.
Okay.
Yeah? Yeah. And also, when I'm saying W is not equal to 0, people are going to be tempted to fake solve that and say that, like, oh, W is not equal to the constant 0. That's not what I mean at all, okay?
Can't be equal to 0 at any time.
Yeah, I'm saying...
Well, that's because fx is
Yeah, because then it would be like the 2z part would be extra, and then that would make it...
Yeah, exactly, because if it was equal to 0 at any x, right? Then this part will cancel with this part, right? And then 1 will have to equal 2z for all z.
Makes sense.
Yeah? So therefore, it can't take any time it can't take the value 0. Yeah? Not only is it not the 0 constant, it can't even touch 0 at any point x. Okay? Okay, that's good.
What is the exact logic for, like, the motivation for, like, making W... Wait, for, like, making f of x squared plus 1?
What is the motivation for making it equal to x squared plus 1?
Yeah, like...
We haven't got any yet. We only have that it works. So at this moment, we're just trying to manipulate stuff and hope for the best. We have... So this is a good question. We have no strong feelings that that's the only solution at this point. Yeah? Right? But we do know it's the only quadratic and it's the only linear. Like, there's no linear and there's no constants. Yeah? Okay. Okay, can you see that if W was a constant, it would have to be 1, right?
Yeah, wait.
Is that obvious?
Wait. Oh, that might not be.
Yeah, like x squared plus c implies c equals 1, basically, yeah? That's what we're trying to show. So you might get some feeling why that's the case, because you know sort of it works that 0 goes to 1 and 1 goes to 2, right? And that doesn't satisfy with any other constants. Yeah? But the surest way to know it doesn't work for any other constants is just sub it in, yeah? Sub x squared plus c into the equation. Just like you subbed x...
plus c is not really... What is time?
7:22.
Starting this concentration.
Yes.
I think we already started like 2 hours.
But I'm guiding you through it, so it's kind of okay, yeah? See? I'm actually doing most of the work for you.
2 hours and I'll still hours.
Excellent.
I don't know what concentrating means at this point. Like...
I can't even sleep today. I'll show you this one.
Why would I
Today.
Why today?
That's what.
It is?
Yeah, that's why I became this.
How come we didn't get a break? I'll show you. Not we.
Michael.
What?
Michael is still working.
Mm-hmm. Yeah, you get the freedom to do what you want. Sometimes you just want to work, yeah?
If I have free time, I just do math. Swim or sleep.
Excellent.
Or sleep.
Yeah, I mean, basically, like, um, yeah. Like, I mean, there's some people who, like, if it's a public holiday or something, they'll force themselves to not do any work, you know? But when they have something to do, they won't necessarily force themselves not to not work, yeah? It has to go both ways. If you're forcing yourself not to work, you have to force yourself to work.
Z squared
Two C
plus
X squared
W.
Y.
Okay, Z squared. Oh, okay. It has to be 1, yeah. But, right?
Yeah, so if it was a constant, it would have to be 1, yeah?
Squared is itself.
And the easiest way to see that is to sub stuff in, yeah?
Wait, let me try that.
Yeah, and I think this organization of the equation gives you a lot of things you can try, yeah?
Squared. Why is it called B3CD? I don't see the person's name. Oh. Okay. Block space single plus column.
Yeah.
C3.
Alright, guys, so the last thing was, can you see why this is true, yeah?
F with minus dot B equals F of 0. Wait.
Yeah, it's actually a very simple game if you think about it. It's just so basically everything you see, it comes from choosing a value of x, y, or z, right? That even rhymes. But like the thing is, that can be hard because there's infinitely many things to choose from, right? But there are always some nice ones that have coincidences. So why is f of minus w always equal to f of 0 plus 1?
Wait, then it's constant.
Yeah.
Oh, then that can be. Oh, then it's the only solution. I mean.
Do-do-do.
Yeah, okay. T. I think this is not the real T shape. This is the real T shape. There is train. Wait. Yeah, this is the real T shape for me. This is the pentameter.
How do you say?
Wait, this is long T. And this is like T. This is small T.
Oh, definitely.
Phase 2 only has one setup.
I'm very bad. For yours. I mean, if W has so much obvious everything except I mean,
Alright, you guys know why that's true?
The
like F negative W is like W squared plus C.
Okay.
And then if W has 1 is C plus 1, then W will get bad.
The thing is, like, if there's a problem that hasn't been solved for a long time, right? Most people won't have the guts to even try it, yeah? But what happens is when someone makes progress on it and they publish like a new result or something in that direction, everyone tries to do something then, right? Because if they make progress that depends on the new result, then they can't be at a disadvantage because the new result just came out, right? So they're all at equal footing to make the next step. So that's why they're all interested. So if you think about this problem, right? What's something that we got? We got this step, yeah? We got this new thing here. Take advantage of it to get to the next step.
wait.
So here this is equal for all z and all x, yeah? And this is true for all x in reals.
So Z is 0. You know, just the same. If Z was equal to 0, then it would be the exact same.
Wow. That's a lot.
Seconds.
Typing just said the Tournament of Towns conference is at 1 a.m. tonight.
How?
You know the Tournament of Towns, right?
Yeah.
So he got invited to the international conference because of his results.
Wait,
Haibing.
Hiving.
Haibing. He'll be here that one day. He'll help you learn stuff. But like, for people who do like well, it's like only like maybe 2 people per state get invited.
So he's a big brain boy.
Yeah, but it's funny because it's like Russian time or something, and it's at 1 a.m. online.
Wait,
All right.
so he has to be up at 1 a.m.
Yeah, if he wants to attend it.
I mean, obviously he's not going to win. What do you even do?
Oh, it's
Obvious.
like a fun. It's like a.
You play games.
Actually, I'm curious too, but I think they present problems. Like, I don't know how researchy they are, but it would make sense for them to be research problems.
Have you done it before, son?
No.
Just jumps.
Tournament of Towns is new to Australia. It's actually one of the better competitions that you have access to.
I don't know. Tournament.
Alright, guys, this is a little bit too slow, okay? So, this is for all z and for all x, right? You're allowed to set z to be whatever you want and still keep the all x, yeah? Pick a nice value of z.
0.
Zero.
Do we know 0?
0 is a real number, yes?
No, like, do we know
Well, we don't have to know f0, we just need to write it in terms of f0, right? Wait, so there's no R's, O's, and R's? People said Z equals 0. Isn't it clear that that works?
Yeah.
Just whatever. It's like, yeah, I see stuff like that all the time. I just don't say them.
I said it like
Oh, okay. We didn't notice, but like that was important, yeah? Gonna emphasize it.
oh
So you set Z to be 0, right?
Yeah.
So Z equals 0. If you set Z equals to 0, then look what you get. You get f of minus w, right? Plus 0 equals
yeah.
f of 0 plus 1.
Oh.
Yeah.
Why are we so slow? Does this, like... Does this actually restrict it enough to have a unique solution?
Not yet, I don't think. But one thing you do know, right? If something is constant, you want for it to be a unique solution, you need W to be constant, right? Yeah. It's not constant, but it kind of behaves like a constant. You think like whatever W is, right? F of it is constant. You see? That makes sense? Like W could be a whole bunch of different things, but whatever those things are, F does the same thing to all of them, right?
Okay.
You see? So that's starting to give you some clues, right? You're starting to think, oh, W might actually be constant. You know what I mean? Because that's not like an easy condition to follow. If W wasn't constant, F would have to be constant on everything W outputs.
Wait,
Right?
so
But
would W have like a
that
finite
is
number
not
of values?
Yeah, F is not constant, right? So that's even more of a
Yeah.
chance that W is constant. Yeah? But the problem is we don't really know what F does, right? So much. But now we know that like it could be that F is x squared plus 1, right?
Yeah.
That's evidence, yeah? It's not a conclusion. But I think it's important like that you sort of direct your energy towards the things which are likely, right? So now you have something, it might not be constant, but hell, it's constant after you do F. Okay? Okay.
So then there's finite number of W's. Like,
Well, yeah, it could very well be constant, but like we still don't know enough about F to conclude it, yeah. But now F has now it's restricted, yeah. So F,
like, W isn't constant, then it's like discontinuous.
yeah. So we have some
Wait,
evidence.
unless like doesn't end. Like, yeah.
Yeah. And so for example, you know, like if F is increasing, right? Yeah. So what does constant mean? Constant is like the opposite of injective, you know what I mean? Constant is like everything goes to 1, right? So like if F is increasing, for example, so all the properties we had, if it was increasing, that's the opposite of constant, right?
Yeah.
Yeah? So W can't go anywhere there, right? If it's 2 to 1, it can't be constant. You know what I mean? So it's starting to look like if you can prove some of these properties, you can conclude something about F. Okay, here's another exercise to see if you understand some stuff. Can you show that if f of x equals 1, yeah, then f of x plus w, probably not the best choice of letters there, is doubled. Maybe I'll put these exercises in at the same time. And if f of x is doubled, yeah, then f of x minus w is equal to 1. Is that obvious?
Isn't that just the opposite of the top one?
The opposite of the top one.
Like it looks.
It's it's the converse of the top one, basically. It's not quite.
Like,
Yeah, it's pretty much the converse of the top one. Yeah. This is. Yeah, maybe next time you can bring the laptops and you can join the chat. The chat's not as exciting as I make it out to be.
okay, I need to join
What
Michael's
chat?
stream.
Do you like stream it on Zoom or what?
It's on YouTube, unlisted. So you just get the link.
Oh,
You get the
no,
link
it's
to the
unlisted.
whiteboard in the YouTube.
Where's the
I need the link to the YouTube.
Yeah, actually the YouTube's pretty good because like, if you miss it, you can rewind it, and you can also watch it at like 2x speed. So there's some parts that are just kind of
Wait, not everyone can watch it, right?
whoever's
What?
on the mailing list can watch it. Yeah.
No, what? How do you get it?
I'm on the mailing list, right?
What's the list? What's the email?
I think so, but I think I've kicked Kevin
Is,
out.
is, is,
Wow, Kevin died.
I never got an email saying that.
Oh, it takes a while to get on the mailing list.
Oh, look,
How do you get on
this
the mailing
thing. Let's
Oh, you have to
go
first give me your email, which
to
is
this thing.
Yeah. What is my email?
making fun
Am
of
I in
us?
the
You
live?
tell me.
Yes. Excellent connection.
Is hiding
Or just give it to
making
me as
fun
an
of
envelope.
us?
your email is your online masculinity.
Wow, this is.
I will give you my email at the end of this.
I should mute this because.
Oh,
Where
Alex.
do you get it? Is it this?
Yes.
Are you sure?
Yes. Wait, I don't know.
The timestamp
No, that's
does not
6. You
work.
need 13.
I like
Where's
writing the book.
13?
Wait, send me a link.
Where's 13?
Johnson, send me the link.
Okay, let me just direct you.
Copy the link. Boy.
Direct. Let me just manually copy it.
HT email.
How do you email? I'll use.
Depending on how
I'm
bad,
just going to send to Stixon.
not how good.
Oh, what?
Yeah, go to Hangouts.
Oh, no.
Let's go hangouts.
Because Hangouts is how it be.
Oh, yeah, that. I tried to tackle it.
Thank you.
I don't know.
What's the delay?
Unlisted.
Is it illegal for me to read the chat and read the answers?
Oh yeah, try not to read the spoilers if you can avoid it.
Oh shoot, there's spoilers.
Yeah, there's spoilers because we're going a bit slow for some of the people in the chat, which is understandable, right?
And my whiteboard still hasn't loaded.
Ah. Wait. Do you understand what I'm saying here? If f of x equals 1, then f of x plus w equals 2 times x of x plus.
Yeah.
Wait, so if f...
If someone played the video and
Oh,
the
wait,
audio went
so
into the laptop, recorded that sound, then played it back there,
Mm-hmm.
and the loop continued.
Mm.
So,
Wait, do you understand what I'm saying? So if something goes to 1, right, then that thing plus w is doubled by the function. Yeah? That's what I'm saying. Or if something's doubled by the function, then that thing minus w has to go to 1.
W was.
So notice that the thing that got doubled would also go back to 1 when you subtract w, right?
Wait, was W.
Yeah, w is the f of x minus x squared thing. W is always going to be f of x minus x squared, yeah? Let's just say that. Not once and for all, but one more time. Yeah, I think in the other class, this kind of problem would go through in like 30 minutes. But here, I think it's fine that you're learning functions. We're actually going through it in like 2.5 hours. But the problem actually took ages to solve. Like, it wasn't like a trivial question. It was like, I think it was interesting because it was like, it got away from the meta of how functional equations usually are. Like, it always usually starts with, like, you can find what f of 0 is. You know what I mean? But here, you can't even find f of 0. So it's like a little bit of a twist on what normal functional equations are. And in that sense, doing lots of problems could actually be bad for you because you kind of stop being alert for the possibilities, right? You're not reading the problem, you're just kind of going on autopilot.
oh, it's no. Typing.
Do you have any idea how to do this question? If f of x equals 1, then f of x plus w is double.
Typing line.
Focus, people. You want to get to his level, you're going to have to start here, alright? Actually, this is the year to do it. You're in year 9 now. Well, some of you. Year 9 is a very fruitful year.
Fruit. Year 9.
Yeah.
Your master's is gonna happen. Just gonna be me still messing around. You're gonna have to start caring about your grades from this and on. Year 9 is their range.
If you're in like in Africa, you'd be carrying AK-47s or something by this time.
Let's go. Let's go. Let's go.
I enjoy it.
I actually want to carry an AK-47 around. It's actually cool.
I've shot an AK-47
But where?
in Las Vegas.
Legally?
Yeah, that's the whole point. If I wanted to do it illegally, I wouldn't go to Las Vegas.
Wait, don't you need a gun license to shoot it? It's one of those.
No, it's like a tourism attraction. So there's like a gun range, and they just let you spam all these like guns that you've heard of.
Is it super expensive to shoot it though?
No, it's like a pretty
Interesting.
like the business side of things is pretty good in the US. Like it's
This is the insert.
Do they have something to
Like,
prevent
bullets
people
are
from
big.
just taking all their guns and shooting everyone inside?
Well,
this triangle way.
Yeah.
so that's the thing, right? Like, there isn't necessarily like the law doesn't necessarily prevent that from happening, right? It obviously punishes it when it does happen, yeah. But it goes to show that there's a lot of rationality involved, right? Like no one actually in their right mind would do that. See, well, not many people. Like not enough for it to be a big problem.
Do you shoot real bullets or just like rubber bullets?
Oh, I think it was real bullets. I don't know. They didn't tell me.
Actually expensive. Bullets are really expensive.
We just assumed they were real. But the thing is, like, how would you know?
Right.
Yeah, just like point at yourself.
I think you'd like get injured
Okay.
either way.
It's like you die a happy man, yeah. Not having
Now
any
I know
uncertainty in
that
your life.
My bullets are real.
Not even for the most trivial fact.
Does you have to be like 16 or above to try it?
Huh?
Do you have to be like a certain age to do it?
I think it's 8. Ooh, maybe it's 21. I don't know actually. It's probably either 21 or
I
18.
still can't figure it out. Like,
I want to shoot it at Johnson's head.
Hmm.
To see what is real.
it's for
see.
science.
Yeah, like it's not as bad as you think. Like the country is not. Like I mean, it has a bad press. Let's say, it gets a bad rap. It's not like all crazy. It's actually one of like. Yeah. I guess it all depends on how much you value freedom.
The us.
It's hard to really understand that.
Traffic light buttons are really
Alright, okay. How do we do this, guys? Listen.
No weird.
Can you see if you sub in Z, if you sub in,
Exciting.
so if f of x equals 1, right? Yeah?
So
Yeah.
One.
Sub Z as like x plus w, yeah?
Wait.
Okay.
Because you want the 1 to cancel with the f, right? You want f of z minus w to be f of x, yeah?
Yeah.
And then that'll become 1,
Yeah.
right? And that 1 will cancel with the other 1, right? Yeah? And then f of z will equal 2z, see?
Oh, that's smart.
I made that.
Yeah.
Ah.
And what's the relationship between z and z minus w? Well, it's plus w, right?
The converse
Wait.
would be like.
Why did it echo? It's because the stream. Oh. I feel like
Is it relatable if you
Okay.
just put like? Is it relatable that you put 5 Nerf bullets into the barrel?
You know, my mom got me in trouble because I shot my sister.
Like, and then you just shoot all of them at the
So
same
it's just like a bruised, huge bruise. Dude, my sister bought me an RC car like 2 days ago, and I took the RC car. I took it with them to her birthday, and that felt great. You actually hurt people. Amazing. Wait, so
You know the
Yo.
stupid
do you have a
sound
gun
effect?
license in the US?
I don't.
Oh.
Actually, probably the most interesting story I have about guns is the shooting thing in Las Vegas, yeah? I've been to like a random shooting range outside of Las Vegas where they like
Do
I
people have to,
fired one of
like,
my friend's guns.
train?
Yeah, he bought a gun. He's super paranoid. Like they're a bit paranoid over there sometimes.
Are they Chinese?
No. He was American. Yeah, but and then the other time it was really strange was I went to some house party, right? It was just like one of my like colleagues at the uni, right?
Mm.
And their roommates were like there was tons of their friends over, right? And they had like the weirdest collection of interests for that one particular night, and they seemed to be ongoing in their whole life, right? So like they were just meeting up to show each other their guns, okay? And their guns were the state of the art. Like they were so modern that they look like toys. You know what I mean? Like they're really light, but they're like heaps lethal. You can tell they're real, right? But like they're really light.
But do they look? Are they like really advanced?
Yeah, really advanced. Like shotguns, assault rifles, all that kind of stuff.
I built my own rock gun.
High tech.
Yeah.
Oh, shoots rocks.
Yeah, and on top of that, they had this huge snake. Like it was like a killer python or something. It was about 5 meters long. It was about this thick, like the thickness of my arm, maybe, right?
Jesus.
And they were kind of just like letting it go all over them and stuff. I was like, okay, well,
Is it a python?
yeah,
Did you touch it?
yeah, but like I immediately stopped touching it.
Might just like eat you.
Yeah, like
It's like-
I'm interested in self-preservation, and I felt like in that environment it might be a conflict to my self-preservation. Yeah, guns would get pretty advanced.
What's the point?
Hmm.
What's the point?
Technology.
I think more than what's the point is just like when something exists, people get obsessed over it, and then like it just advances.
Knives.
Like if any one thing has like a following, you know.
Knives. And look at my 600
Graphics so good.
that I don't even use.
But you know, sometimes the advancements actually make it safer, right? You don't have like misfires. You don't have like,
Technology.
you know what I mean?
Yeah, but that.
It's like everyone has better.
Oh yeah, my sister bought me a little RC car for my birthday, and it had 2 motors. And
Yeah.
the 2 motors into a little Nerf gun that
Mm.
actually can do some damage.
You know, like those extremely light mouses.
Oh,
All right, guys. So
They
actually,
have like the perforations.
so look, if you have f of x equals 2x, right?
Yes.
You just sub that in for x for z, right? And then the f of z and the 2z cancel, yeah? So let z be x in the second one, right? And then f of x will cancel with the 2x on the right, yeah? And then the f of z minus w is equal to 1, yeah? You see that?
Yes.
Yeah, so that's kind of
Yeah.
cool, right? So actually another way to say this, which might be illustrative to learning about some functions. So there's a one-to-one correspondence, which is another way of saying bijection. So bijection is like, this is why you have injection and surjection. If you have both, it's called a bijection. Yeah?
Wait, how do you not have both?
How do you not have both if you
Yeah.
don't have one of them?
Wait, how do you have injection but not surgery?
Like if it's infinite, right? You can have like a function that doubles, like if you have the natural numbers.
Yeah.
Right? If you
geometry next lesson.
Yeah, that's what you can choose, right? We have geometry, number theory, algebra.
Oh, geometry.
One of them.
Yeah.
I do need to improve my algebra hat.
Wait, how do you have a
Well, complex number is a big topic in algebra, let me just say
Stop
that.
it.
And functions too.
Wait, how do you have an injection that's not surgery?
Yeah, so if you have like the functions from naturals to naturals, right? If you just double the number, like f of x equals 2x, yeah?
Yeah.
That's injective because no two numbers go to the same number, yeah?
Wait, how do you have that but not surjective?
Well, you don't get any odd numbers, right?
Oh, okay, got it.
Okay. Okay, so actually there's a bijection between the two sets. So there's a
Yeah.
bijection between the things that go to 1. So another way of saying that is the pre-image of 1. Okay? And the set of all things which are doubled by f. Yeah? There's actually a one-to-one correspondence between the two sets. Can you see that? And it's given to you by w. See, because anytime you have like something that goes to 1, right? You just add w to it, yeah? And you get something that's doubled, yeah? And if you minus w from it, you get back to the thing that goes to 1, yeah? So you have basically a function that goes there and back and undoes itself, right? So there's actually a correspondence. The correspondence goes like this. The thing that goes to 1, right, is sent to thing plus w, right? The thing that goes to double itself is sent to thing minus w, right? So there's actually a one-to-one correspondence between the things which go to 1 and things which are doubled. Yeah? So this is a little bit of an aside. It's kind of extra learning. But like, you can also describe it in a nicer way. Because w is actually dependent on x, right? Like not the x over there, but it has its own f of x, right? you can actually have, it might not be constant, it could have other values, right? So another way of saying that is the number of one-to-one correspondences between the two sets are in one-to-one correspondence with the values of W. Sorry, I don't mean to make it like I'm not trying to sound smart by saying all this spammy stuff. Like I actually know that smart people don't find like jargon smart, yeah? It's more just like I'm kind of giving you a view of the future, okay?
A view of the future.
Yeah. Like when I was your age or even older, I was kind of skeptical about jargon, right? Because I guess, yeah.
Is it good to focus during school math or not?
Mm-hmm.
Is it good to listen during school math lessons or not?
Yeah, I think
only bad if you use it bad.
I mean, I try to make the lessons work so that you don't have to learn the same thing again in school. Yeah. So when you're learning in school, you should be learning some new things. Yeah.
You should.
And when you are learning new things, right?
Mostly tutoring.
No,
Mostly like format tutoring.
But like, yeah, but even if you're learning something you learned before, the way that you can approach it can be different, right? Like the quality of the proof, you can actually like something that you know is a fact could be known with certainty, or it could be known via authority. You know, like the certainty you can actually guarantee, and you can listen to their proof. Does it stand up to your reasoning? You know, there is stuff to be gained from school. Otherwise, you shouldn't even go to school. Really, we have to make the most of it. Okay. Yeah, so it's actually kind of crazy, right? There's a one-to-one correspondence between two sets. Yeah? The set of things which go to one and the things which are doubled. Yeah? Another thing that's crazy is those one-to-one correspondences are in one-to-one correspondence with the range of W. Right? Because for every different value of W, you can add W and minus that value of W. Right? So that's kind of crazy. So let me illustrate how something cool can happen with this. Maybe instead of illustrating, I'll set it as an exercise and I'll reveal it. We're running out of time, so maybe I'll just reveal it. Okay, so can you see that if f of x equals 1, right? Yeah? And w is not constant. Yeah? Then f of x has to equal 1 infinitely often.
Wait.
No.
And W no wait, how's that relevant?
Well, w not constant is the thing that is preventing us from making a conclusion, right? And if w is not constant and it's equal to 1 infinitely many often, like that really goes against any of those properties we came up with, for example, right? Because our thing, like one happens once, and then it's never one again, right?
So
but this is happening one all the time. Yeah.
So it's like if f of x is 1 at some point, then it has to always 1.
And that's a problem because a lot of these things, right? Look at this. Like if you take like this value, like f of z and f of z minus w, right? They differ by like 2z minus 1 of them, yeah? So it's sort of like the gap is growing and growing, yeah? But it can't be growing and growing, and at the same time it has to come back to being equal, you know what I'm saying? So that's what f of something equals 1 means. It keeps coming back to being equal. Then how do you prove something like this? Well, it's taking advantage of the different values of w, okay? Because what you get is, you get f of x equals 1, right? So then x plus w goes to 2x, right? X plus w goes to double, right? Yeah? And then x minus w goes back to the original thing that goes to 1. Yeah? But you could do x minus w with a different value of w. Yeah? So that it won't go back to the original thing. It'll go somewhere in between, right? So you found something else that goes to 1. And you can just keep doing that. You can go up by something and come down by the other thing. And so you're always going up by the difference. You know what I'm talking about?
I'm confused.
So say w of like something, like w of a equals like t, yeah?
Yeah.
And w of b equals u, yeah?
Yeah.
then what you can do is you could do like f of x plus t, right? And then minus u.
F of x plus.
Yeah, because when you plus t, it gives you something that's doubled, right? And then when you minus u, it gives you something that goes back to 1 again. Yeah?
Yeah,
But if t is not equal to u, right?
Oh, I get it.
Then that difference can be added on and on. Yeah? So then you get infinitely many things that go to 1. Yeah?
So it keeps looping.
Yeah. Yeah. So look at this. So this might not contribute to the final solution, but like it should definitely contribute to convincing you that f of x is very likely to be x squared plus 1. Yeah? Like, if you could even prove a hint of it increasing and all this stuff, it can't equal 1 this many times. You know what I mean? So having it equal 1 infinitely often is a very strange and contradictory property according to what we sort of understand about f. Yeah? Yeah, not only is it infinitely many often, it's unbounded. Yeah? Okay, so now we're getting to this point. All right. So we actually did this one in the chat already, but basically if f is not 2 to 1, is either 2 to 1, yeah? So we were investigating the surjectivity just then, basically, right? Now let's investigate this injectivity, yeah? We could have done that one for a lot longer. Actually, I think it gets somewhere, but this one gets somewhere faster, I guess, and we don't have that much time. So f is either 2 to 1, yeah? Or periodic.
Wait, how's it 2 to 1?
Yeah, okay, so good.
Wait, it's 2 to 1 if W is constant.
So this is kind of like a new train of thought here, yeah? So we're kind of starting a new train of thought. So if you go back to the original equation, yeah? So if you go back to the original equation, and actually if you came up with this train of thought first, you probably would solve the question in like 5 minutes. But like, it's not necessarily the most natural thing to try first, right? All those other things I think lead somewhere too. That's what makes the question kind of maybe unintentionally tough, because a lot of things actually work. It's just not all of them work immediately, yeah? So look at the original equation, yeah? Assume f of, so remember what injective was? F of A equals f of B. Remember that? The same output have to be the same input, yeah? So assume f of A equals f of B, yeah? Okay. So what you want to do is you want to sub x equals A into the equation, yeah? You sub x equals A, yeah? Okay. So I guess you want to sub x equals A and sub in x equals B simultaneously and compare what they are like, yeah? So notice the first term. If you sub f equals A or B, it would be the same, right? Because f of A equals f of B. Does that make sense? So this term here makes no difference whether you sub in A or B, right? 1 obviously makes no difference whether you sub in A or B, yeah? This term makes a difference, yeah? Because it'll be A squared or B squared here, yeah? But the last term doesn't make any difference, yeah? And Y obviously doesn't care what you do to X, yeah?
Yeah.
So actually,
that's the only difference.
Yeah, so that's the only difference. So it must be the same, right?
Yeah. So
That's a funny way to say it.
must be the same. Wait.
It's probably the worst way to say it, but the point is,
Wait, what?
f of A squared plus Y has to equal f of B squared plus Y. Yeah? Is that right? Because all the other stuff is the same, right? So that has to be the same too.
Yeah.
That's funny because it was different, right? And so it's good to make different seeming things equal, right? So this is true for all Y, yeah?
Yeah.
So you can replace y by y minus b squared, for example. Yeah? So you can shift it over by minus b squared. Or another way of saying that, you can let z... Like, y is a dummy variable anyway. Because it's just taking the place of... It ranges over all the numbers, right? So you can replace y by, like, another dummy variable, z minus a squared. Yeah? And then you get f of... So z minus a squared plus a squared is just z, right? Equals f of z plus b squared minus a squared.
Yeah.
Right?
Yeah.
And because z's a dummy variable, it might as well just be y, yeah? So then it makes it more clear that we just let y be shifted by a squared, right? And so what does it mean to be 2 to 1, right?
That's... Yeah, okay.
Because that looks like it's periodic. You know what periodic means?
Yeah, it looks like it's...
Periodic just means like the value repeats every certain interval.
Wait,
Yeah?
unless
So in this case, this would be the period, yeah?
Wait.
Exactly, yeah? So
Yeah.
this would be periodic unless b squared equals a squared, right?
Yeah, but then that was a contradiction.
So b squared equals a squared is what 2 to 1 means, right? Because b squared equals a squared means
that
either
means
b equals...
one's like positive, one's negative.
Yeah, so b equals either plus or minus a. That's 2 to 1, right? So b could either be one of two things, a or minus a, right? That's what 2 to 1 means. So if it's not 2 to 1, b is not equal to plus or minus a, then b squared minus a squared is not equal to 0, right? And that's the period. That makes sense? That's the period. So it's either 2 to 1 or periodic. Okay? So if anything, if basically I'm saying if f of x equals f of x plus like 3, right? Yeah? That's something that's periodic with period 3. Yeah? Like an example of a periodic function that you'll learn in school is like the sine function. Yeah? It repeats every full revolution, yeah? So the period is 2 pi, yeah? Makes sense? So you have f of x equals f of x plus 2 pi, yeah? And and you might wonder why you even have like periodic if it's repeating. Well, it helps because you never have to check the things in the domain anymore, right? Like the angle sum formula is good because you never have to check the angles actually add up to something inside 360 because it's defined for all real numbers. As long as adding up gives you a real number, it's fine, right? There's lots of advantages to having it defined for all real numbers, even though it's just repeating trivially, right? Okay. So it's periodic, okay? Periodic is also against the properties that we're looking for, yeah? Okay.
Yeah.
Maybe we can actually find out what the period is, yeah? Can we try to find out what the period is?
Wait, x squared plus...
So can you see...
So b squared minus a squared is...
Can you show that f of a half is equal to f of a half minus w? Alright, so this is the current exercise. We don't have that much time, so we're going to have to go through it a bit quicker. F of a half equals f of a half minus w.
Welcome to us.
Okay, so can you see how to do that? If you're not focused on it, I'm just going to reveal it, and that's really bad for you. It's really bad for someone to tell you how to do something that you can already do. That's like the worst thing, and it wastes time too. And the only way to tell that you can't do it is by trying and failing. Yeah. Okay, I might have to speed through a bit. So okay, just sub z equals a half, yeah? You see? Then the half z, the 2z cancels with the 1, right? Yeah. So this is like your a and your b, right? So the period is b squared minus a squared. You know what I'm saying?
Yeah.
So the period can be expressed as w times w minus 1. Yeah? Difference of two squares, yeah? Just add them and subtract them. And it doesn't matter if it's plus or minus, right? Yeah? Because the period doesn't matter if you're plusing 3 or minusing 3. It's always 3, yeah? Yeah, so the period is w times w minus 1. Yeah? Okay. So we might have to skip one of the steps and see. We'll go straight to this one. Yeah. Can you see that? Can you see that f of w minus 1 w, right, plus 1, yeah, is equal to f of w minus 2 times w plus 2 times w minus 1 times w. You see that? You see why this is true?
Plus 2.
So,
Sub z what?
that's W.
Times w? Yeah, exactly. If you sub z as w minus 1 times w, see that's z, right?
Yeah.
Yeah?
And then you sub it.
And then you go to minus w, right? So that's just w minus 2 times w, right? Right? That's what you get if you minus w. And then the z is just this again, right? So you get this by setting z equals w minus 1 times w. Yeah?
Yep.
Okay, but let's evaluate this. What do we know about this?
W.
Can you tell me what this would be? Almost there, guys. Almost there. Then you can process the rest of your learning in your sleep.
Actually, I did.
Yes, with neuron reinforcements. And hopefully it'll disconnect some of the retarded neurons formed during the holidays.
I mean, still, wait, is it week 1 now? Or is it still the holidays?
I think it's week 1.
Yeah, because some schools start on a Friday this week.
Yeah, and some schools start like Wednesday this week and then Thursday this week.
I start next week
Really?
on Monday.
Oh,
When do you start?
interesting.
I start on Monday. Right. All the other schools got the timetable like 2 weeks ago. I still haven't gone to my classes.
Yeah, see, look, guys, what's the point of having f of w minus 1 times w, right? That's just the
Wait.
period.
That's the period. Oh. Wait, yeah.
So what does it mean? What does it mean to be the period?
Means that if you add it, then it'll be the same.
Yeah, like if you add or subtract it.
Wait, but then it's
It wa-
adding an extra 2 times W minus 1 times W.
Yeah, but you could also
So,
subtract it.
Wait, but then it's different. Wait,
Can you see that f of the period has to equal f of 0?
f of the period.
Because it's squared.
Yeah, you just subtract the
Yeah.
period from it, right?
Yeah.
Yeah. See, logic links up. Okay, 1 doesn't change, right?
Can we
Yeah.
say that it's
Yeah, I like this. This is very good instincts. Yeah, so you have good instincts. The good mathematical instinct is to find relationships between things, yes? Possibly the only mathematical skill. So, okay, what's this then?
That's an extra W.
Yeah.
Yeah, wait. If it's periodic, it's f of W.
It's periodic. We're assuming it's periodic because otherwise... Actually, yeah, what's the conclusion if it's not periodic?
It's f of minus W.
Well, we'll explore both conclusions, yeah? F of minus W, yay!
Yeah.
Plus this, yeah?
Plus weird thing. Yeah.
wait, but doesn't wait.
And Mario.
Can you see these are equal, right?
Wait.
These
Wait, because that's twice the
twice the period is
twice the other one.
What do you... wait, so, are you convinced that this is that?
Wait.
You just plus a period to it, right? Like the period is W squared minus W, yeah?
Yeah.
If you minus W, like minus W plus that is just W squared minus 2W.
Yeah.
Which is what that is, right?
Yeah.
So this is actually f of minus W, right?
Yeah.
But f of minus W is equal to f of 0 plus 1, right?
Wait, really? Oh,
Because
yeah.
that's what George
yeah.
said, remember? From earlier.
Yeah.
I was complimenting his keen relating skills.
Wait, so then 2 times f of... 2 times
Yeah,
f
here,
of-
right? In pink, can you see? Now it's in black as well. Yeah?
Yeah. Yeah. Yeah.
So they cancel, yeah? They're equal.
Yeah, so that must be 0, but that doesn't...
So then what do you get equals 0? You get W minus 1 times 2 times W equals 0, right?
yeah.
W is 0.
Wait, but that's twice the
Wait, that means that
Yeah, the
W
2
is...
obviously is never 0, yeah?
That means W
Wait,
has to
so-
be 0.
Huh?
so
Remember we said W could never be 0.
Or 1.
W could never be 0, right? It can't even momentarily be 0, yeah?
Wait, no,
So-
not or 1, or half. Wait.
What?
Wait, I'm stupid. Wait,
One
I'm having a brain dead moment.
Jeez.
Yeah, I'm brain dead.
Alright, don't worry, I'll get you through this. So look, W either equals 1 or W equals 0, yeah? W is never equal to 0, yeah? Not even a little bit.
So it's W.
W has to be constant in 1, yeah?
Yeah.
So f of x equals x squared plus 1.
Yeah.
But look at the other conclusion, yeah? We didn't explore both conclusions. What if A was actually equal to plus or minus B, yeah? So obviously A can't equal B, yeah? A equals B means half equals half minus W, right? And then W equals 0. That's not allowed, right? But A could be minus B, right? And you get half equals W minus a half. Which gets you W equals 1 again, see? Yeah. So actually, a lot of it just contributes to your understanding of the problem, right? If you want to actually write up the solution, what would you actually have to write? You know what I mean? You'd write like, let's just try to find the stuff you'd actually put into the solution. Like you could even avoid this if you wanted to substitute cleverer values, but sometimes you wanted to make sense as well, right? So if you just wanted to write the solution, you just need this, right? Yeah. You just need this, yeah. You would just need this and the 2-to-1 periodic thing, right? Yeah. And then this would finish the problem, yeah? So your final solution is only like 5 lines. Okay? But it doesn't mean the other stuff didn't contribute, right? Like you wouldn't necessarily go like if the question was prove that f of x equals x squared plus 1 is the only function, that's a different question, right? Then you might go straight for the jugular, yeah? But here, you don't know what's gonna be. You need evidence, right? So it might not be the most efficient, like it actually might be more practical just to always assume it's the only solution and go for it. And you'll get 3 out of 5 Olympiads or something. But that's not a skill worth having, you know what I mean? Like you'll get the 3 out of 5 Olympiads and nothing more.
True.
Yeah? Whereas this skill, you can even get 4 out of 5, 5 out of 5 Olympiads, plus all the benefits of having done those things, you know?
Oh yeah, oh yeah, go.
What is that? What is that video? What is that? What is that?
Pretty star.
Wait, I need to see this. I need to see this.
Why does your channel have a video?
Oh, you know, like that's the stupidest video in existence, but it just instantly became my second most popular video. Literally all I do is solve this. This is the most retarded problem in the universe. Nintendo Switch, you start Mighty Pops, right? It doesn't ask you for 2-player mode. So you're like, are we doing 2-player mode or 1-player mode? Alright, whatever. How do we get 2-player mode? Okay, you have to actually play the game for the first 5 minutes, pass the tutorial, and then the second player activates.
How does this have 4.1k views?
Yeah, I don't know. And then half of them are dislikes. How can you dislike this? I don't understand. If you're viewing this, you can dislike this.
It's just an informational video.
So it's like the people who wanted to find out how to do it, they couldn't figure it out still. That's why they disliked it. I literally have 2 videos that are popular. That one, second most retarded video ever. And this other one where I basically just click like this stupid in-game slot machine for 5 minutes.
This is YouTube algorithm.
I recorded that for 5 minutes. And that has like 15k views. Like all it does is convert the coins to gems in a stupid like app game, right?
Cookie Field Casino.
Yeah.
Do you play?
Brawl Stars, Paw Patrol. Oh yeah.
So you play Brawl Stars?
Look at Brawl Stars. Insane 14. Wait, what? Commentary. It's a commentary channel.
Let me see that video.
10-3 and 10-6.
How do you get 4.1k on the retarded?
Yeah, and then half of them are dislikes.
How do you dislike a video like that?
I don't know how you
It's
like it.
informational.
It could lead to a like, a sub, or a dislike. I don't even know how that's possible.
There is literally nothing. Oh boy.
Oh no, Marcus Smart. I hate Marcus Smart. I got the flop on bro.
House of Crab Palsy.
Yeah, like those ones, no one views them. Like anything that's interesting, no one cares. Like perfect play on a game, no one cares. Educational value on a game, no, don't care.
Stupid video.
Teach you the thing that you care about most in life, no. How do you watch someone slot machine for 5 minutes?
Where do you watch NBA stuff? Do you have to pay for it?
I used to like last year, but now I just watch the highlights.
This is your most popular video. Which one?
Yeah.
54k. 54k.
Yeah, I basically just press the slot machine for 5 minutes.
How? You know you can start making
It's
money after you get
RNG
10K.
manipulation.
No, you need to get.
Firstly, we need to reverse reverse engineer the RNG algorithm. Well, as you can see, you use
Sir, teach me how to get 50K views on a stupid video, please.
generally use Xcode to make.
I actually want to know. Fair efficiency rating. No, Carl Ari's too fat to be an FB. He's actually too fat.
And look, what's this video?
Wait, sir?
301
When do you stop playing
Why do
golf?
YouTube videos?
Oh, when my sons
Ah,
start
yes,
playing.
back then
Still play?
when it used to.
Sometimes.
Oh, play with him. He's really
I
good.
play enough to finish the season.
Wait, what?
I like how you have one video
How
per
does that work?
logic game. Like,
Wait,
wow.
What?
Every single logo.
No, I had this thing. I had this book, right?
Oh.
And it had like QR codes linked to the videos. That's why it's one video per.
Oh.
Oh yeah.
Johnson's very addicted to Brawl Stars. Very much addicted. Yeah. They're very good at the game. Yeah.
I want to see the most popular.
Okay, you do videos.
Am I good?
How many? How to play?
I have a lot of those. Oh, I'll go.
That's the most popular.
What was?
Okay, cooking theme and casino commentary
What was
is
your
literally the
answer?
most beautiful.
What was your new answer to
New
classic
answer.
riddle?
Ice, Boolean.
And how is isomorphism of Boolean algebra the fourth most viewed video?
I don't play the game.
I want to see comments. Oh,
I
there's
see
zero
more.
comments.
Here we go.
There's zero comments.
Oh yeah, you can go now, by the way.
Oh, okay.
I want to see the comments.
What was your new
I need
answer
Jen's really bad at orders up.
to?
I
don't like
recommend
you.
this bad.
What was your new answer to God riddle?
Oh yeah. So the old answer is you ask
Yeah.
the guy to ask the other guy, right? But you can get him to ask himself.
Yeah.
Wait, so you know
I
you can,
thought of that a few days
you know you can
ago.
watch the NBA. You know you can watch the NBA game free online, right?
Oh, I don't know how.
Pirated. There's just lots of websites.
Thank you.
Oh,
I
okay.
thought it meant the directional pads. That was so frustrating.
My friend paid for it, and it's like pretty
What
cheap.
is this?
Okay, so let's see. Cooking fever casino commentary. How to play
I'm
two
gonna go
players.
through and watch all these videos.
You answer the classic riddle. Isomorphism
Wait, so
of
do you have
Boolean
one?
algebra.
No.
Carl Lowry takes
No, I don't have
another
enough.
shot. Find the in radius of a 5, 12, 13
How
triangle.
much do you need? Thank you.
Actually, a lot of my YouTube is just spam. I'm just spamming videos, and then I don't even like put descriptions in there and stuff.
Quantity over quality.
Just like random crap. Dude.
Like I like how all the math videos have like two.
Player efficiency.
Yeah, no, like
rating.
less than 2 sometimes.
There's one with one video.
Circle inscribed
I mean,
inside
I watched it.
hexagon AIMO 2015 question 2. I guess a lot of people got stuck on that one. Wait, what? A 3-digit number equal to the sum of the
But if you
powers
think about
of
it,
the
AMO is not like for a lot of people.
Okay. You just write a Python.
Let's see. King code
No, right.
This is a video that-
It's way faster.
was made.
It's faster,
Faster
but this
to
is tiny.
John Jason.
Huh?
Let me see. What is what?
It'll still save you more time if you. It'll still save you more time
Yeah.
I own.
because Python has less syntax crap.
No.
What's the code?
And your
Yeah, Python
ID.
is actually faster.
No,
Less time to.
But
Oh,
I thought you have to
basically
deal with all the indentation stuff.
Yeah, but your ID will do that for you. Like, or text editor just.
If you
Yeah, as if Notepad.
Well, yeah, but why would you only have Notepad on your computer?
Why would you code using Notepad?
Why would you code using Vim without indentation?
Oh,
order?
The main thing, Jason's basically edited all this. Okay, that's not the best one. I'll show you.
Video.
really bad. Michael's is just spam, so it's like. So I
Alright,
don't
guys,
know.
have a good night.
Okay.
I'll see you online or next week.
Turn it down.
You know when you
Watching his video.
Or his videos.
Thanks,
Alright, thank you.
You know when you look at your video and sin at some effects I don't know what.
Hmm.